Hi, Wasim. Remember? Hello, hello.
Hi, Vivian.
Remember to record.
Yep.
Everybody told you today. Remember record. How are you?
Yeah, all good. Thanks for joining the session.
One moment, please. My phone is not good. One moment.
Very good. Hello, all. We'll just wait another moment or two as people enter the Zoom, and we'll be starting up very shortly.
Now everybody listen me?
Oh, yes.
Okay.
For anyone who is having technical difficulties, who would like to receive some one-on-one support, if you want to put the show of hand button, there's a raise a hand button in there, and we can arrange to connect with you in another channel if you need any technical support. It's probably possible to get a lot out of the event without having your own copy of NodeXL running, but it's always nice to have. So we're happy to help you if that is necessary. All right, and I think we're almost at full.
Yep, it's looking good.
Very good. It's so nice to see you all here. A good morning, good afternoon, good evening. Let's see, and we've got a chat which we'll be monitoring. I did send out a list of URLs and resources yesterday. Did everybody get that? Did anybody not get that email with the list of URLs and resources? Okay, well, very good. With that, I think we're ready to roll. Wasim, what are your thoughts?
Yep, we can make it start. So
okay. Very good. Welcome, ladies and gentlemen. This is the February instance of the NodeXL training introduction class. We'll note that there is an intermediate class coming up in March, and there'll be an advanced class in June. With us today, we have Dr. Wasim Ahmed from the University of Newcastle in the UK, and Harold Meyer, who is in Germany, just north of Frankfurt. Both of them members of the NodeXL team. We also have an emerging member of the NodeXL team. There's Vivian Francos in Haifa. Hello, Vivian. And let's see, do we have any other returning folks? No, I think everybody else is new. Oh, well, there's Satish. Hello, Satish. Good morning, or good evening, as the case may be. I'm going to hand it over to Dr. Ahmed, and he'll be providing us with an introductory presentation. Thank you, Wasim.
Thanks, Mark. So I'll begin sharing my screen now. So thanks everyone for registering for this event. In this introductory part, I just want to introduce the general topic, today's workshop format, a bit more about the speakers, some suggested reading, and today's schedule as well. So in terms of the schedule, I'll talk briefly for around 20 minutes, just on the background about what is NodeXL, how it can be used for the analysis of social media data, and some initial insight and an overview of a recent research article we wrote using NodeXL. Then Mark, who we've just heard from, will take over and talk about some background to social network analysis, some terminology and key theory that underpins NodeXL. We'll then have a short 15-minute break, and then after that, Harold will lead with a practical overview of NodeXL, key features, Twitter networks, and a hands-on tutorial on how you can use NodeXL yourself to kind of retrieve and manipulate data. We'll have another short break after that, and then Harold will be back for part 2 of the practical overview, showing you some more tips and tricks with NodeXL for retrieving and analyzing data. Then Mark has a summary of the overall workshop and some future projects that the foundation is working on that's likely to be of interest to you. And then at the end, we'll have a Q&A session. and feel free to use the chat window to add your questions, and then at the end we can kind of go through them. And Mark's already mentioned this, but in March we do have an intermediate event. So today we're going to show you how you can use some of the introductory features of NodeXL to retrieve data and analyze it. But you can go even a step further with more advanced analytics and analysis. And we are running an event on March 26th on Friday, showing you some more advanced kind of insights into NodeXL. So I do recommend having a look at that if you're interested in learning even more about some of the more advanced network features. And today, just some general tips. Make sure that the microphone's on mute. We're not contributing. If you have any lag issues or if it's a bit slow, one tip for using Zoom is to close any unnecessary applications, and do feel free to use the chat to ask any questions throughout the workshop, and we will be collating those and kind of answering them at the end and also throughout. A point on NodeXL. So NodeXL requires a license to run, and everyone that registered should have received a NodeXL trial license. Please let us know in the chat if you didn't get one of those, and the team can send you that. The team is also offering one-to-one orientation sessions, which Mark mentioned. So if you've not been able to get that already, you can drop us a message and we can organize that as well. We're also sending out certificate of attendances as well within 7 days after the event, a PDF certificate. And again, let us know if you don't receive that. We're also active on social media today, so we will be tweeting using the hashtag NodeXL. So if you are on Twitter and active on the platform, it'd be great to see your tweets about the session today. So Mark, who was speaking earlier, is a sociologist, and Dr. Smith is the director of the Social Media Research Foundation and leads the Connected Action Consulting Group, and have delivered a number of talks with Dr. Smith in the UK, as well as in Boston University a few years ago. Harold is a geographer with research interests in the spatial configurations of online networks, and he founded the Digital Space Lab in 2011 and works as the chief data scientist at the Social Media Research Foundation. And I've also delivered some talks with Harold as well in the past. My own interest in NodeXL and social media analysis came through my PhD thesis, which analyzed information around pandemics and epidemics. So I was looking at disease outbreaks on social media, things like swine flu, Ebola, and the Zika virus. And I was looking at different software that could kind of analyze social media data for my research. And I found that NodeXL was amongst one of the easiest to use, and had access to the Twitter API that could actually get me data, and I could use it and analyze it. So that's where my interest kind of came in social media and social network analysis. And just a note on the Social Media Research Foundation. So the Social Media Research Foundation is a collection of academics from all around the world, including marketing professionals, that really help to kind of support the NodeXL software package and kind of help it to be where it is today. And we're supported by a wide range of academics across different disciplines as well. And I'm sure Mark will talk more about the foundation as well. And one of the reasons for kind of having access to tools for academics to be able to analyze data is the kind of recent rise and burst of various platforms, things like Facebook, LinkedIn, Instagram, and more recently TikTok. There's a lot of data out there that's being generated, and academics have been using some of this data to get insight into public views and opinions across a range of disciplines. And by doing so, kind of writing kind of research papers, conferences, and so forth. Some of these platforms are more open with their data. They provide more data than others. So Twitter, for instance, the session today will be using examples from Twitter and showing Twitter data sets. And the main reason is because Twitter provides almost complete access to its stream of tweets. And it's a really open platform in terms of connecting to it and retrieving and accessing data. But some of these other platforms, it can be tricky to kind of extract that data. And another reason for studying social media data is because of the vast number of people connecting to social media platforms, but also connecting to the internet as well. So although not everyone who uses the internet is on social media, tweets are still embedded in news stories and shown in the media and so forth. So social media platforms might have a reach that kind of extends a bit further than the platforms themselves. And again, it makes it really important to have the tools and knowledge to get that data and analyze it. And hopefully today we'll be showing you some of those methods. There's also a vast amount of data being collected. So almost 200,000 tweets are sent every single minute. But all of these other platforms are kind of generating a vast amount of data as well that we can really tap into. And what NodeXL is essentially a plugin for Microsoft Excel. A NodeXL kind of appears in Excel once you've installed it. And it's the network overview, discovery, and exploration for kind of analyzing social media data. And it provides access to a number of different data streams and advanced metrics as well, things like text, sentiment analysis, and powerful report generation. And it doesn't require any programming knowledge or skills as well. So really anyone can kind of learn and use the software. As I mentioned before, it has a number of key features, and in Harold's practical overview, they'll be showing us how we can use NodeXL for network analysis, network metrics, cluster analysis, vertex metrics, also for content analysis as well, text analysis, sentiment analysis, top content analysis, time series, as well as producing nice visualizations to accompany the data and providing insight into that. And it's all automated as well. So one of the key features of NodeXL is that it has access to kind of algorithms that will automatically analyze this data for us. Whereas some other tools are a bit more manual and might require a lot of human input to kind of get the outputs that we desire. And although today we're talking about Twitter and kind of social media data, we published a review a few years ago looking at where NodeXL had been used. We found at that time that NodeXL had 7,000 academic citations, but that number has increased quite a lot now, so it'll be higher than that amount. And we found that NodeXL had been used not only for social media, but other academics had used it to study things such as Blackboard discussion boards, personal email networks, internal security, medical data analysis, political sponsorship, and news stories, and even campus-based social media platforms. So essentially, any network-based data that has connections between two entities could essentially be added into NodeXL and analyzed. Recently, for a research group I'm involved in, we managed to add in the research interests of different colleagues into NodeXL and actually draw visualizations based on people's research interests. So it's got a wide use case that kind of extends beyond social media. In terms of further reading for today's session, the book on the left-hand side, I recommend this to all my students as well. It's a really nice, neat book that starts with no prior knowledge and kind of shows you step by step how we can go from importing data to making a visualization in a kind of step-by-step format. And it's based on showing you examples with NodeXL. The two books on the right-hand side are more general social network analysis books. If you're interested in the methodology and you want more information or kind of insight into what social network analysis is, I recommend those two on the right-hand side as well. And a link to all of the slides today will also be sent to you as well, so you can refer to this afterwards, as well as the recording. There's also some nice articles out there as well. So this one is one of my favorite articles, Mapping Twitter Topic Networks from Polarized Crowds to Community Clusters. Essentially, when we analyze NodeXL datasets, different topics represent different shapes, and we can use guidance to interpret what those shapes mean that come out of social networks. So this article takes a look at how we can interpret some of those different structures and shapes, and it's the go-to paper when kind of analyzing a particular network and seeing what shape it might reflect. So I recommend having a read of that as well. And just to kind of summarize and finish off, I thought it'd be useful just to show you a real-life case study of a piece of research that we did that looked at the 5G conspiracy theory around coronavirus, around COVID-19, and how we use NodeXL to get data and analyze it from Twitter. So the 5G conspiracy theory said that the technology, 5G, the mobile phone masts being set up to kind of increase the bandwidth of mobile networks, was actually spreading COVID-19. So that was the conspiracy. And at first I thought, no one can really believe this. It's unlikely that people are taking it seriously. But then I started to see reports that 5G telecom workers had been attacked. I saw videos on social media of them getting a lot of abuse and people recording it and uploading it on social media. And over 20 phone masts were attacked, vandalized in the UK and Europe. And especially there was one at a hospital that someone had vandalized as well. So it was getting a little bit out of hand. So we use NodeXL to get data on a specific hashtag related to this conspiracy. And we were able to produce a visualization, and Harold is going to be kind of showing you how you can do that yourself. And as I mentioned, there's guidance out there on how to interpret these different shapes and structures. But I just wanted to draw your attention to one particular group, G4, which we labeled the activism account. And what we found was there were accounts set up that were connecting to other users with the sole purpose of telling them about the conspiracy theory. So actually saying, did you see this? This is the real conspiracy. And they were able to spread that message. And eventually Twitter removed this cluster and these accounts, but it sent out many hundreds of tweets before they were actually shut down. And kind of NodeXL allowed us to map this network out. And again, using tools in NodeXL, we found which users were most influential. And both Mark and Harold are going to be talking about something known as the betweenness centrality score as well, in terms of detecting influential users. There's also influential web sources that NodeXL allows us to detect. And we found fake news websites such as InfoWars really came out as a popular web source. And again, NodeXL allowed us to find this insight. We also found that there were websites selling protection or claiming to sell protection against 5G kind of radio waves, clothing and so forth. So they had a vested interest in potentially trying to profit from this. So they were pumping out articles saying that 5G is not safe, it might be causing the pandemic and so forth. So with a potential financial interest as well. And again, NodeXL quickly allowed us to spot this. We also followed up with some content analysis, and NodeXL also allows us to do some automated content analysis on our tweets as well. And it also allows us to spot most popular tweets as well. So most frequently occurring tweets, most frequently occurring retweets as well. We can find out what domains were most influential. So we found a lot of people using YouTube to share videos, and this result kind of gives us that insight. And based on our findings, we made a number of public health recommendations around how social media companies and public health authorities could help to kind of fight misinformation as well, and some general recommendations for the public as well in terms of how to report social media content, how some of these accounts could have been shut down a bit sooner as well. And the paper was well read as well, so we've got a pretty decent metric score, and again, thanks to having tools like NodeXL, we were able to get that data and kind of analyze that as well. So it was useful to have access to the Twitter API and rapidly kind of get that insight to be able to write some of these papers. And I think that's it for the introduction of NodeXL, just some background and so forth. So I'll pass over to Dr. Smith, who'll be talking you through more of some of the theory about kind of social network analysis and so forth. So I'll just stop sharing the screen here.
Wasim, I'm going to have to ask you to make me a presenter in order for me to have screen sharing.
Yep, sure.
Okay. Well, good morning, afternoon, and evening. I'm Mark Smith. I'm a sociologist, and my goal is to produce sociology of the internet, which is a broad area of endeavor. In order to do that work, my aspiration is to bring a few methods to bear, and those methodologies are, as no doubt you'll have noticed, network theory, but the other two are collective action dilemma theory and interactionist sociology. And I hope that'll all become clear in just a moment. So let me move you guys off to the other side and put this up on screen. There you go. So hi, I'm Mark. I'm a sociologist. I'm in California in the United States, and our organization, the Social Media Research Foundation, is an international one that has attracted people from a variety of backgrounds. Many of the participants, there's Wasim, these are computer scientists, information scientists, communications professionals, professors. There's Harold, computer scientist, information professor, political science, information science, computer science. All of these people come from a variety of backgrounds, often from the social sciences and the computational sciences, but they share a common interest in wanting to be able to say things about the internet, about social media, that are grounded empirically, objectively, quantifiably. There is this phenomena out there, this kind of flocking behavior, and it calls for some explanation or description. We are now immersed in social media, but it is a, as yet, poorly mapped landscape. How many kinds of hashtags are there? What are the types of message boards? How do you know when certain kinds of dynamic events are taking place? Many of us spend a lot of our time in social media, but few of us have the methods to actually step back and away from social media and see its not just micro, but its meso and its macro properties. And so this is a murmuration of starlings. Maybe you've seen these birds flocking. And it is a kind of metaphor for what we see with social constructs like hashtag or discussion group. Nobody is telling people to tweet with a particular hashtag. People are just converging from many directions and forming different structures. But there is a way in which this metaphor is exactly wrong for social media. And that is that starlings are not like human beings in the sense that they are all equal. And I think I have never been in a room with other human beings in which all the human beings were equal. If human beings were birds, we wouldn't be starlings, we would be chickens, because chickens have a pecking order. So what's wrong about this image if these were humans? Well, some of the birds would be big birds. And when they say left, everybody would do what that person says, what that bird says. These birds, every bird's doing its own thing, and this just emerges. But with humans, some people are more in charge than others. And we'll be discussing just how many of those people there are. And just to give away the punchline, less than 1% of the population of these social media spaces demonstrate properties that show them to be influential. And so what we are interested in doing is conveying some of the ways that network theory, collective action dilemma theory, and interactionist sociology can actually be crystallized in software. And there's a piece of software, that's NodeXL. And the punchline of this image is to say the number 10 is a wonderful number, one of my favorite numbers, but it is inadequate to the representation of the 10 dots over on the other side of the screen. There are 10 dots there. But the idea is that the volume of things is insufficient to the understanding of the structure of those things. And so if you look at a lot of social media reporting tools, they will tell you things like how many tweets, how many followers, how many retweets, how many users, but they will not tell you how well connected. They will not tell you who is the most connected or the most strategically positioned. And that's a shame because the pattern of interconnection actually tells us very important stories about social media. The question we should ask is, what is the question? What do we want to know when we come to social media and we want to ask questions about it? And our organization argues that you probably want to know things like, who are the leaders? What are the factions? What content defines the leaders and these subgroups? And how do things change over time? And so we're arguing that knowing how many things there are isn't enough, because here we have two boxes of Lego. They both have 717 bricks, but one is the X-Wing and one is the Minecraft. Knowing how many is not enough. We have to know in what way are they connected. So our aspiration is to provide scholars with a way to answer this question. What does a hashtag look like? What does my hashtag look like? How does it compare to some other hashtag? And when I use the word hashtag, I certainly would be happy to remove that word and replace it with a different phrase, which kind of means the same thing, but in a more generic way. And that would be collection of connections. That we are interested in collections of, and a particular kind of connection, annotated connections, collections of annotated connections. Somebody did something with somebody and there's a bunch of text on it, or there's a little blob of data hanging off of it. And so one question that is worth asking is, why draw the data? Why should pictures be the goal? After all, we're living in an era of big data. Why don't we just give you some numbers? And we have numbers, and if you would like numbers, we have lots of numbers for you. But this fella, Anscombe, Anscombe's quartet is a famous piece of statistical argument in which the challenge is to look at these numbers and answer a few questions for me. Questions like, do you see the outliers? Do you see any potential errors? And you see that there's 4 distributions here, 1, 2, 3, 4. Each of them is an XY coordinate pair. Which of the 4 is the least like the others? If you were going to pair them up, which 2 go together the most? And there's a lot of you, and I'm guessing you're smart. And we're now approaching about, let's see, there's about 17 people in the room. So that's a minute of human brain time per. So that's 17 human minutes of brain time. And the question is, are we getting anywhere? Well, maybe we need help. How about statistics? There are some statistics, but Mr. Anscombe's very clever. All of the XY pairs have the same statistics. Summary statistics. Different numbers, same average, same variance, same mean. And so we're not getting anywhere because this thing, the grid of numbers, is actually relatively new. 1604, Mr. Descartes comes up with this. But there is another way of showing you this information which will let your brain answer all of the questions I've asked you and do it in less than a second. In fact, it'll do it in less than 400 milliseconds. Would you like to hear your brain say, oh, here we go. Ready? I'm going to advance the screen. Oh, same data, presented differently. I suspect your brain is now saying something to you like, well, why didn't you just say so? Why didn't you show me the information in a format that I spent, 1.5 billion years on the planet developing the input modality to be able to find where is the ripe fruit? Where is the thing that has the right shape? Where is the right pattern? Is there a tiger in the grass? Our brains, our eyes are really good at that. And they're really bad at this. I don't know about you. If there's anybody on the call who's really good at this, call me later, okay? But very few humans are very, very good at this. But they're very good at this. And so that's why we are going to try to draw a picture of your hashtag. And again, not just hashtags, collections of annotated connections. And once you start looking for them, you'll see that these collections of connections are everywhere. So what's it going to take? We have questions. All of you are scholars or you're practitioners of one sort or another, and you have questions about social media. We have questions like, which one's better than the other? Or we're doing something in social media, is it working? How does it compare to some other effort that we made? Who are the important people? And new for 2016, invasion and manipulation. Is there some concerted effort to manipulate these environments? And I will note, it's very hard to tell when something is happening that is abnormal when you have no idea what normal looks like. And so we are seeking to create a kind of atlas of social cyberspace. And with that, we would be able to say, the thing about this part of the planet is that it's very, very flat. And that we know it's flat because this is another part of the planet and it's very, very mountainous. And you can tell that someplace like, like where if you go to Nepal, they've got mountains. And if you go to Kansas, they do not have mountains. And so geographers know a little bit about the differences of the surface of the earth, but sociologists, we're just starting to map the surface of the social landscape. And in order to do that, we're going to need tools. And, the geographers often drew maps that were a little fuzzy. And sometimes they would have an arrow and they would say, this way lie dragons, right? You know, we didn't really know until we launched satellites. And now we know. We know every square millimeter of Earth. Nobody is going to see a newspaper headline then that says, undiscovered continent found in the Pacific, right? We've seen it, but we haven't seen it in social media. And so as a sociologist, I can say, crowds really matter. Crowds, of course, are now very dangerous, but this was from before COVID. And hopefully there'll be a time very soon after COVID where you could actually get into a crowd. But the sociologists say all of history is actually achieved by two or more people working together. Very few things happen because one person does them. And so the challenge for the sociologists these days is, even before COVID, most of the crowd behavior had moved online. And looking at crowds online is a challenge in the same way that Anscombe's quartet is a challenge, in that you could read the tweets, and you're welcome to, but there's a big problem, and that is there are more tweets than there are you. So how many tweets can you read in a minute? I'm going to give you 10 tweets a minute. How many tweets in an hour then? So that's 600 tweets an hour. How many tweets in a day? Well, if you're dedicated and you don't take too many breaks, maybe 4 hours of tweet reading in a day. So that puts you at somewhere between 2,000 and 3,000 tweets per day as a human being. But many of these topics are generating 2,000 or 3,000 tweets per minute. So what are you going to do? In the United States, I don't know how many of you are in the United States, but has anybody ever heard the story of there's a fella named John Henry? John Henry, is that a name that rings a bell? Wikipedia may have your story here, but I'll tell you. The story of John Henry is he's a guy in a mine. He's digging a tunnel for the trains to go through, and he's the best guy in the mine. He swings a sledgehammer better than anybody. And then they bring in the steam-powered mining machine. And Mr. Henry is a little irritated. He's got competition. And so he challenges the machine, and they have a contest, and he beats the machine, has a coronary, and dies. What is the moral of our story? Don't be John Henry. Right? If John Henry was sort of, well, if he had the philosophy that I would like you to have, the proper thing to do when you find a steam-powered mining machine is to ask the boss man to put a seat on it. And Mr. Henry should say, my job is now to sit on the machine, which is to say, do not compete with the machines, sit on them. And what can they do that we cannot? They can read hundreds of thousands of messages. And if they could distill them, if they could squeeze that orange, if they could pull that espresso shot, you could drink little sips of concentrated tweet insight, and you could consume that in a way that, well, the machines have made it so that humans can generate more content than humans can consume. And that's a problem. And since the machines cause that problem, it's their fault, and they'll have to get us out of it. And so in what way can we do that? Well, here we could spend hours reading tweets about an American politician. And I'll just note, 4 years went by, I never updated this slide. But this is what it looks like when we look at the people talking about that politician. Each of the little squares, that's a Twitter user. And the lines between them are relationships. The relationship in this case is I replied to you, I mentioned you, I said your name. And we can see that not everybody has the same structural properties. These people over in group 3, they have connections to no one but themselves. They tweeted, but no one said their name and they said no one's name. They are what we call isolates. They have zero connections to anyone else. They are isolates. But over here, these people are very connected to each other, but they have relatively little connection to the other people over here. And these people have a lot of connection to themselves, but relatively little connection over here. And then having found that this is a cluster and this is a cluster, NodeXL went in and found out what words and hashtags do the people in this group use, and what are the hashtags and words used by the people in this group. Well, I did make their colors represent their political orientation, but maybe even if you're not Americans, you can tell that if you say forward on climate and Wall Street sales tax, you're not a Republican. And if you say Tea Party and GOP and TCOT, there's a good chance you are. And so for the non-Americans on the call, it's important to remember that we have two political parties in the United States, a right-wing party and a far right-wing party, now a proto-fascist party. And so what you're seeing are the two divisions in American politics, corporatism and fascism. Welcome to America. So networks are really the way that the universe is organized. A lot of things are connected to other things, but not everything's connected to everything. There's a difference in how connected things are. However, network as a concept is pretty rare to find outside of mathematics and computer science. We do not typically think link. If you are a social scientist, you often are trained that data is an attribute of an entity. People have incomes, they have height, they have shoe sizes, they have blood types, they have educational attainment. And these are the attributes of individuals. And that's great. They do have individuals exist and they have attributes, but sociologists recognize that there are other things about people that are important, and critical among them are their relationships, the connections they have to others. And so often when you draw these images, these collections of connections, the result is disappointing. In the same way that it is possible to take a camera and take a bad photograph, not all network images are good images. And we, part of our team, are exploring ways to make it so that you can get better images, and preferably with as little actual labor on our part as possible. Remember, our metaphor is don't fight the steam-powered mining machine. Insist that someone install a seat on it. You belong on the back of the machine, not fighting against the machine. And so we seek to explore tools that will enable human beings to collect and analyze, visualize, and communicate to other people. That's our most important part. Communicate to other people insights into collections of connections. And it turns out the universe is made out of collections of connections. Everything, it turns out, is connected to something, but not everything's connected to everything. And some things are more connected than others. And so we are exploring various ways of representing networks, collections of connections, not all of which are great, some of which are better than others. But when we draw these pictures, and I should note this is a cartoon, this is not real data. But I did spend 10 years at Microsoft from 1998 to 2008. And the only thing that I will say about the image is that the only error is that the weapons were much bigger. We used heavy machine guns. You know, basically the idea is that Microsoft was several fiefdoms and they did not get along. And if you ever wondered why Windows and Office don't seem to like each other, there's the answer. But these other representations try to convey something of the culture, the feel, the uniqueness of one organization versus another. And it does that with just circles and lines. And you may not yet be fully trained network theorists, but I bet you can get a feeling for what is trying to be conveyed here. Some of these organizations internally could have the same number of people, but internally the shape of the culture, the social structure is different. And when we say social structure, we don't mean that as a metaphor for some intangible thing that can never be actually grasped or measured. We mean it as a very practical, objective, quantifiable, empirical thing. It is the expression of relationships between people. And one of the great advantages of being a sociologist over being, let's say, a psychologist is that sociologists can see relationships and psychologists cannot see thoughts. And that's a big difference. Now, maybe psychologists will soon see thoughts, not going to tell them they can't. My mom's a psychologist, I'm going to get in trouble. But right now you cannot see a thought. But if I see you sit down and have a meal with somebody, I see a relationship. Now you could say, well, you don't know the quality of the relationship, but I know a lot of things about the relationship. I know how often you sit there. I know how long you sit there. I know whether or not, let's say you make phone calls to a person or if they call you back and how long the calls are and what time of day. So relationship is really critical. So our aspiration is to make it as easy as possible for scholars to point a device into the world, press a button, and get an image. And this was the first thing that converted photography from a profession to a hobby. Before this, you really had to be a chemist and a carpenter in order to be a photographer. And then after this, you really needed $5 US. And for $5, you got this wood and leather box filled with chemical film, and you could press the button up to, I think there were 15 exposures in the box. You brought it back to the chemists, and about 3 weeks later, they would give you another box and 15 images. And so this is Instagram 1.0. What we would like to do is bring it into the future. Maybe it could become the disposable camera or the digital camera. Of course, this thing is now obsolete. Nobody will ever buy one of these ever again because you have this. And this is sort of what we want to be. We're not on your phone yet, but we're getting there. We want to be the kind of point and shoot digital device that you can point at a crowd, but not a physical crowd, a virtual crowd. And when you do that, you get something that looks like this. You get a tool that actually gives you a ribbon in Excel. All the other ribbons are still there, the menu ribbons. We just add the NodeXL Pro ribbon. And critically, it's got these little labels at the bottom of each of the boxes in the ribbon, and that's helpful to look at. Most people don't see that at first, so I'll just direct your eyes to these locations. There's the data, get me data and send my data somewhere else, graph, visual properties, analysis, options, show, hide, and help. And so in NodeXL, if you would like to get data from, let's say, Twitter, you would go to the NodeXL Pro menu, click on Import, and you would get a menu. And this menu contains the endpoints of network data that NodeXL is designed to connect to and import. And actually, we have a few more. We've added Wikipedia, and we have a few less. Mr. Zuckerberg took away the Facebook opportunities, so no more Facebook. We're not happy about it either, but Mr. Zuckerberg doesn't call and he doesn't write, and we never get any feedback from him. But you can get YouTube and Twitter and wikis and blogs and email and other network data sets like UCINet and PIAC and Gephi and just edge lists and matrix files. So if you've got a network data set, there's probably a way to get it into NodeXL. And let's say we wanted Twitter, we would select from Twitter, search network, click, and we get a dialog box. And in that dialog box, we specify what would we like to know more about. You type your query here. For the first time use, you'll have to click this button. I have a Twitter account, but I have not yet authorized NodeXL to use my account to import Twitter networks. Take me to Twitter's authorization webpage. So the first time you come through this, quick question, do you have a Twitter account? You have to have a Twitter account. And then you have to tell NodeXL what your Twitter account is. And then having done that, it will let you simply come over here and hit OK. And when you hit OK, minutes may go past, could be 5, 10, 15 minutes, but then this shows up. And what is this? Well, that's Excel. It's a bunch of Excel worksheets in a workbook. And there's a graph image. And the graph image, if you click here, lights up over here. And if you click over here, it lights up over there. And each of the worksheets conveys information about a different aspect of this network. The vertices worksheet is information about each dot. The edges worksheet is the information about each connection. And so the most critical thing about NodeXL is this button. This is the Automate Run button. This is a lot like the button on your camera, if you still have a camera. I remember about 4 or 5 years ago was the last time I bought a fancy camera, and regretted it because it was too fancy. I could never really figure out how to make it work correctly. But it did have a button on top, and it was labeled IA. And they claimed that that stood for Intelligent Assistance. And I thought the I might mean something else. And it basically made it possible for me to use the camera. Now I simply focused on focus and zoom, and it did the rest. And that was great. That's a lot like Automate Run. Automate Run is in many ways the most pivotal feature of NodeXL. It's the thing that says, this list of operations are the operations that should be performed on this network data set. And I'll note that each of these operations might have options, and these options might have options, and the options, it could go on for a while, because each of these things is a step, not unlike, let's say, petroleum refining. Each thing is done one step after another in order to achieve a final result. So that's the bad news, that there are many, many, many steps. Here's the good news. You don't have to know that much about them. We have a notion in NodeXL called recipes. And we have Twitter recipes and YouTube recipes and Flickr recipes. And each of these recipes is designed to check all the boxes appropriately for that kind of data. And so if you like the results that you're seeing other people get from NodeXL, you can take their recipe and apply it to your data. You'll get different results, but the same look and feel for that pattern. So do we have recipes for Instagram? Well, the problem is that Mr. Zuckerberg runs Instagram. And he has cut the world off from access to data on his platform. So Instagram and Facebook, you just don't get data from them. If you can get your data some other way out of Instagram, and what way would that be? Potentially manually. Then the answer is yes, we can do that. We'll show you some interesting research examples where people manually generate network data sets, in part because in some cases the network data sets are not digital. Right? There are networks in the world that predate the internet. I'll show you very shortly the work of Dr. Diane Klein, who studies the social network of Alexander the Great. And she notes, Dr. Klein notes, that Alexander the Great did not have a Facebook page. He was more of an Instagram guy. And so it is possible to find networks in all sorts of places. They don't have to be online. Now, of course, online networks are of particular interest, and we make it easy to get to them. So each of these steps, and in many ways, this dialog box and this dialog box resemble the syllabus of my 3-quarter introduction to social network theory that I took in, I think, 1993 with Phil Bonasich at UCLA. Instead of taking 9 months of your life to learn network theory, what we have done is boiled it down to a dialog box. Now, of course, like that fancy camera, if you want to not hit the run button and turn on each of these things one at a time yourself, you're welcome to do that. But even if you do that, there are good reasons to use automate and run, particularly if you're working with a group of people, because otherwise people tend to process their data in idiosyncratic ways. And when you use a recipe, everybody uses their data in exactly the same way. And that can be a really good thing. So let's see. So this is the vertices worksheet. This is one row for each person in your network. And this is the edges worksheet. This is one row for each connection in your data set. This is who did what with whom, when, and where. Here's the who, vertex 1. Did what, column O, the relationship. With whom, column B, vertex 2. When, here's the tweet date. Where, well, we actually have latitude and longitude in some cases. Often not. About 1 or 2% of tweets have latitude and longitude. But people often tell you what time zone are they in. And they'll also tell you a human readable name for a location. They might say Big Apple or London or, you know, Edinburgh. And so NodeXL has ways of turning Edinburgh back into a latitude and longitude and plotting it on the map. We'll talk about that in a little bit. So this is the edges worksheet. There's a time series because not all of this happened all at once. People are connecting to each other over time, and you'd like to know perhaps if I have to go and read a bunch of tweets, maybe I should just read the ones in the 5 o'clock hour because that's when things got hottest. That could be interesting. In some cases, we have been studying misinformation and disinformation. And it's been very interesting to see the person who was the first to mention a new topic right before it got big. That can be very interesting. So knowing not just the spike, but the time right at the before the spike, very interesting for the diffusion of information. So this is the content analysis feature. So here we are in words and word pairs. We've clicked options. This is the dialog box that allows you to customize the language being used in NodeXL. This is the list of words we should ignore. We call them skip words. You just, you know, these are little words that you don't care about, and that's fine. If you care about those words, you can remove them from this list. This list is editable by editing. You just click on it and do what you like in that list. And you can scroll to the bottom and add more words to this list. So if there are certain words that you know are specific to a dialogue, but just don't matter, you put them on this list. And then we have 3 lists, and they have names, but you can change their name. We gave them the names positive, negative, and angry, violent, and we've populated them with American English because we talk different out here. American English. So for those who are Anglophones, you know, we don't spell color with O-U-R at the end. And so you might prefer the UK variant, well, not of that kind of thing, the variation of our recipe. And you can. You can just reach in there and change the words. And, you know, we even have a better recommendation. Positive and negative, it's kind of binary. It may not fit your data that well. I'll give you an example. What if we were looking at automobiles? And the category positive, negative, and angry just don't fit that well. And we have the notion that 3 different categories of words, 3 different vocabularies would be better. And what would those vocabularies be? We're talking about cars. It could be that we have a list of words about economy. How affordable or expensive to run is the vehicle? We could have another list of words, and it would be about performance. How fast and how much fun is it to drive the car? So we have economy and performance. Maybe we'd have a third category. This will be safety. And this is words like airbag and safety belt and crash bar and, you know, that kind of stuff. And maybe it's like consumer reports is a word that would be about the safety of the car. And so we have affordability, performance, and safety. And the joke is pick any 2, right? You can have a fast, safe car, but it's not going to be cheap. You can have a cheap, safe car, but it's not going to be fast. So you can pick any 2. And so we might want to repopulate these lists of words in such a way that it is tailored to the topic better than the generic positive and negative. So why did we populate them with positive and negative? Because our users asked us for sentiment. And that's pretty close to sentiment. But many of our users then discover that they develop a very negative sentiment about sentiment. Sentiment, the idea of just positive and negative, it's kind of facile. What you might want more is words that talk about the topic of interest in a particular way versus another way. And NodeXL will help you identify these words because it will do content analysis, and then you might be able to use words and put them on different lists. So we'll show you that soon. So when you do these kinds of reports, you end up with networks, network visualizations, lists of the top influencers, lists of the top hashtags, we'll have top words, we'll have URLs. And the goal here is to make it so that you have a kind of situational awareness. You are no longer like John Henry. You are able to see 10, 20 hashtags, and you're able to be aware of what's going on in them at a much lower labor cost. You're no longer incapable of seeing the forest because you're paying too much attention to the leaves and the branches. Now, of course, the goal is eventually read a message. That's a good thing. We want you to read a message, but we want you to read the right message and not just all of the messages in the hope that having read 10,000 messages after 10 hours of work, that somehow you're going to come away with the answers to important questions. And the challenge with doing it that way, just reading a lot of tweets, is that, well, we've talked about it, it doesn't scale, but it also does not get past reviewer number 2 particularly well. Reviewer number 2 says things like, what if you had looked at a different group of tweets? What if you came back the next day? Would it be different? How does that compare to some other collection of tweets? And you just don't have the resources to go that far. And now you do. And so we are interested in outfitting a planetary cadre of researchers who will each take the tool as if it was a camera and point it at the things of local interest in their part of the world. I'm an American, so I only speak American. We don't even speak English out here. We don't speak any other languages, and we never hear about other countries. It's if you ever look at our weather report, there's no Canada and there's no Mexico. There's just America. And so you are the experts. You know better than I do. I can't do all this research. I just don't even know about the topic. But I might be able to make you a camera that will let you take a photograph of your phenomena and hopefully do this with it. If you head on over to scholar.google.com and type in NodeXL, I think Wasim mentioned this at the beginning of our presentation today, you will see that we are now, I think, past 7 I think we're past 8. We're on our way to 9,000 publications. I assure you, we didn't write all of those. And so we are very interested in facilitating the development of a research community that is going to be able to point this tool into lots of different places and come away with, in aggregate, a kind of atlas of social cyberspace. And since this is the landscape that we are all living in, it might be useful to know, well, what kind of hashtag am I in? And what would I like it to be? And how would I change it? And so we are the Social Media Research Foundation. We're at smrfoundation.org. And we also maintain this website. This is the NodeXL Graph Gallery website. And on this site, you will find lots and lots of NodeXL datasets. And when you click on them, let's go take a look for one that may be of some interest. Many of them pop up all over the place overnight. And I think, let's see, find a good example here. I know. How about anti-vax? I like that one, or don't, as the case may be. So, some of this content is not benign. I think a lot of people have a newly developed appreciation for disinformation and its potential pathologies. People who tell you that COVID is a fake, that vaccines don't work, that you shouldn't wear a mask, those people, well, that is kind of like a virus itself, right? I mean, if you tell somebody don't wear a mask and they don't wear a mask and they get COVID and, kill somebody, that's a bad thing. And so the idea that there is this kind of marketplace of ideas is an idea. How many people here are familiar with the idea of a marketplace of ideas? Anybody? Marketplace of ideas? If you check the Wikipedia page for marketplace of ideas, the idea of the marketplace of ideas is that there are good ideas and there are bad ideas. Same way that there are good cars and there are bad cars. People tend to buy good cars and not bad cars because they talk to each other and they discriminate between different products. It's a shame that's not true, right? Because most marketplaces are not unregulated. Most marketplaces actually have a lot of regulation and controls over what can be said about products. I can't tell you that your new iPhone now includes teleportation. That's not going to work. You don't have the right to say anything you want about your product. And so the idea of the marketplace of ideas is actually one in which people use that idea to suggest that there should be no regulation of things like social media. And I'm all for freedom of expression and free speech, but that doesn't mean that I'm all for misinformation and disinformation. And so there are people who are opposed to vaccination. I don't know, vaccination is the single greatest contribution to human health on Earth of any technology ever. Not even clean water compares to vaccination. But the question we might ask is, who are the people who don't like vaccination? Those are the people who don't like vaccination. And some of them are being talked about because I'm sure Pfizer likes vaccination. But these are the 10 most influential people at the center of talking about anti-vax. These are the 10 URLs most central in that discussion. And critically, you'll see that just because there are the top URLs across the entire graph, that does not mean that the URLs most frequently mentioned in this group are the same as this group or this group or this group. In other words, it is not a monolithic structure. It is highly structured. It has lots of little clumps, and each of these clumps has its own attitude or orientation to the issue, which we can see when we look at top hashtags. Here we see the hashtags that are most frequently used across the entire discussion, but it's worth noting that the hashtags used in group 1 are not necessarily the same as group 2 or group 3 or group 4 and so on. Not all of the groups are talking about the topic in the same way. And at the center of each of these groups, a different person is at the center. A different influencer is present. And so instead of having to deal with 10,000 people and somewhere around 7,500 tweets, you can look at this report in perhaps a minute and cover a lot of ground and maybe have the answers to the questions that reading 10,000 tweets would have generated in a way that you can then cover a lot more territory. So let me just flip back to...
Hi, Mark. Just let you know, 5 minutes left for your presentation before we break.
Understood. Very good. I will just leave you then with, whoop, there we go. All social media has networks in it. If there's no network in your data, then it's not social. And everything we're doing in social media forms networks, and all of those footsteps leave a durable pattern behind that allows us to tell a story about what's going on in a collection of connections. We know how many people, which way did they go? We know if they came alone or in groups. We know, did they come with animals? Did they drag a wagon? We know a lot. And so as you go about your day, swiping and tapping and clicking, you are mostly making connections between yourself and some other piece of data, and by its proxy, some other person. And so all of these different ways of connecting create edges, links, ties, bonds, associations, relationships, and all of the different platforms have this. They just have slightly different kinds of connections. Wikis are not blogs, blogs are not YouTube, YouTube is not Twitter. And so it will be the different shape of those networks that will determine in what way are those things the same or different. So what network theory is really all about is the answer to the journalistic question. And the journalistic question you may know as the 5 W's. Sometimes there's an H. This is different than the vowels. This is not A, E, I, O, U, and sometimes Y. This is who, did what, with whom, where and when. Sometimes there's a why, sometimes there's a how. And so our invitation to you is to think link, to think about the associations, the connections, the linkages between entities, rather than asking the question, how much does A earn or where do they live? What we want to know is, does A have a relationship with B, and does B have a relationship with A? And of course, it could be that A and B share a relationship. And it could be that A and B have both have a connection to each other, but it's imbalanced. B calls A 5 or 10 times for every time A calls B. And so these edges, these arrows, can contain metadata like how much, how often, when. And of course, there is those relationships that should be bidirectional. There is the ever popular is married to. Sociologists have studied this. If you find that you are married to somebody who is not married to you, we recommend counseling. But you're not supposed to be able to be married to somebody who's not married to you. Some of these relationships have to go in both directions. So whenever you can express a connection between thing 1 and thing 2, person 1, person 2, business 1, business 2, entity 1, entity 2, what we want to convey to you is write it in a spreadsheet in a single row. The who, the did what, the with whom, the where and when. And whenever you do that, you are expressing a tie. You're expressing a connection. And NodeXL will do this for you automatically with social media data, but you may want to do it manually with, as I mentioned, Diane Klein did it by reading ancient Greek texts and writing down who said what to whom or who did what with whom, as evidenced by some piece of text from ancient Greece. And so this is what it looks like when you are looking at edges from Twitter. There's a who, there's a did what, a with whom, a when, sometimes there's a where, there's the actual text. And so it's the details of who did what, with whom, when, and where. And you can write this yourself. And all you have to do is get things into the right columns, and your data becomes a network. And so what's the difference between the edge attribute and the vertex attribute? The vertex attribute is only an attribute of one of the people. The edge attribute is only an attribute of their connection. So if you call me, a vertex attribute is your phone number, but an edge attribute is the time the call started and its duration, right? Because the time the call started and its duration is meaningless unless we have the two phone numbers to provide context, whereas your phone number is meaningful so long as it's tied to you. And so some things are the attributes of the individual, some things are the attributes of the relationship. What we will find is that these patterns of connections form, well, patterns. These collections of connections form patterns, and these patterns, there are at least 6 of them for networks that have the concept of reply. If they have replies, you can get these kinds of patterns, and you'll see these patterns demonstrated in this report was mentioned earlier by Wasim. If you type the word NodeXL Pew into Google, you'll probably get this article, Pew Research, Mapping Twitter Topic Networks. And in that report, you see these different patterns. And these patterns tell us something about the nature of the data that we're looking at. And if we jump back here, you'll start to see these patterns in the NodeXL graph gallery. So I will, I think, leave it to Harold to pick up the story from here. I believe we also now have a break. Is that correct?
Yep. So we have a 15-minute break, and then we'll go over to Harold.
I think we have a point from Harold before we break. So go ahead, Harold.
I have one suggestion. Mark, could you present your slides on the centrality metrics, just to explain those for the next 5 minutes, and then we go into the break?
Yeah, that's a great idea. Let me do that. So what Harold is asking me to do is very quickly show you, I think, this before we jump into his part of the talk. And we're going to get to centrality, you'll see. So the important thing in network theory is that we add the middle of the sandwich in your data. Let me say that less obliquely. We know that a lot of your data has information about the individual, and a lot of your data has information about the total population. Networks add the meso layer, the idea that this is not just one big population, it's actually a bunch of little groups or subpopulations. So it's the micro, the meso, and the macro. So in network theory, the key concept is that things have attributes based on their connections to other things. And so here's just a bunch of random dots labeled with letters of the alphabet. And what I'd like to do is now show you how we could come up with a number for each dot. For example, this is, let's make the dot bigger and redder in proportion to the number of lines that touch it. And we're going to give lines that touch it a name. We'll call it degree. Now, if the lines had arrowheads on them, then degree breaks it to 2 kinds, in and out degree. In degree are a number of lines that point to me, out degree is a number of lines that I point to other people. Now, the interesting thing here is that Z and A and O are big dots, and Y and X and W and I and K are small dots. And that's because only one line touches I, but 1, 2, 3, 4 lines touch O, and 1, 2, 3, 4, 5, 6 dots touch lines touch Z. Okay, so the things with a lot of lines, they may be important by some definition of importance, and that's true. Another word for degree might be popularity. Okay, but wait, why is O not big now? We've changed. We're now looking at betweenness centrality. Why is O small? Let's go back a second. O is big. O has many connections. O is now small, still has many connections. Same network, didn't change. Why is O not a big dot? A very important question. Why is O not a big dot? And why is F and Z, why are these still big dots, but O is not? And the answer to the question is, what would happen if O was removed from the network? O disappears. Is there anybody who is no longer able to connect to somebody because O is gone? And it turns out the answer is no. All of O's connections are redundant. Somebody else can get you there. And so if like O was like a bus line and you wanted to go from the city of L to the town of N, and you had to ride the O bus line to get there, and O went out of business, what would you do? You would go on the M bus line, or you would go on the P bus line, and you would get to N just fine. And so betweenness centrality is the how much are you the bridge? How much are you the gatekeeper, the linchpin, the thing that stretches between two otherwise separate clusters, the connective tissue? And it turns out another word for this is influence, thought leadership, power. Now, you could argue, look, popularity is power. I have degree. I'm the most popular person. Don't tell me I don't have power. That's fine. But betweenness is a different kind of power. And so imagine there's a big sales team in a big company and there's 200 people in sales, and the most popular person in sales knows 100 people in sales, but there's another person in sales and they only know 5 or 10 people in sales, but they know 5 or 10 people in engineering. That person has betweenness centrality because they are a bridge between otherwise separate groups. And you'll see this in our network graphs. The people at the center of these little wagon wheel structures over my head here, these people often have betweenness centrality because they connect not only to these people, but they'll have one link over there and they'll bridge between clusters. And mathematically, sociologically, we can argue those are the people at the center of our neighborhood. These are the influencers. It's not about what they say. It's about how they connect to others and how others connect to them that determines their position and their power in the network. And when we look at these patterns, we're able to say it's not how many connections, it's how distinctive, unique your connections are. And so some of these people are not like the others. They have much greater power, and it will turn out that there aren't that many of them. There are very few people who are at the center of the conversations. If we look at these maps, we'll see that most of the time, the network is structured in a way that most people are relatively passive or inactive, and a tiny number of people are the people at the center of these wagon wheel structures. And those are the people who are the thought leaders. And how many of them are there? Not many. Not many. Less than 1% of the social media population play the role of being the hub and the hub and spoke pattern. And that means that, well, social media makes a promise And people actually hear it making two promises, not one. Social media makes one promise: all may speak. But people hear a second promise, that all may be heard. And social media never made you that promise. It did not say that you would be heard. It said you could speak. And what we see in these graphs is that many people try to speak, but only a handful, less than 1%, sit at the center of these structures in such a way that they are the thought leaders. This is both good news and bad news. On the good news side, if you're trying to influence a conversation, you have a very small number of fulcrums to focus on. There are only 10 or 15 people at the center of every discussion on Earth who are the most influential people in that discussion. That's the positive. The negative is there's only a few people running every conversation on Earth. Now, the positive thing is you can identify them and engage them. The challenge is, what if you wanted to be one? It might be better to just make friends with one than to try to knock one of these people out of their perch. And that's another suggestion from network theory, that you might want to know and build relationships with the most influential people rather than to attempt to be the most influential person. Because being influential takes a lot of effort, a lot of labor. So let me just check with Harold. Did that cover the topics that you wanted touched on?
Yes, perfect. Thank you, Mark.
Did I miss anything that you would like me to add before we hand it over?
Yeah, I think that's for the intermediate session. So we take a closer look at the other centrality metrics. So that's a good start for now. And I think we can do our break now.
That's right. Okay.
Cut this the break to 10 minutes from now, and then.
All right. Okay, folks, we're taking away your break time, but okay, we're going to break. I have 26 minutes after the hour here. It's 6:26 here. Let's do this at about, 10 minutes from now. So 6:36, 6:37, or 37 minutes after the hour. And we will go into, let's see, what do we do here? Stop share. And there you go. Okay, I'm going to turn off my camera. We'll see you back in 10 minutes. I'm going to get more coffee.
See you in a bit. Well, okay, I think now it's time to proceed with a practical overview. I hope you're all done with your break. And okay, now it's time to learn more about the key features of NodeXL. So, well, just a second here. Yeah. So at first, so getting started, we have to talk about the system requirements. So NodeXL is built for Windows operating systems. If you're a Mac user, you can use the NodeXL Cloud Edition. Further, well, you need Microsoft Office Excel, and it's always good to have a 64-bit system so you can make use of the RAM on your machine. And how much RAM do you need? Well, 4 maybe for very small networks. 8 is pretty good. Well, 16 is better. With 16 gigabytes of RAM, you can do a pretty large network analysis. And that brings us to the question, how large a network can we analyze? And well, like I said, that depends on your machine. If you've got a good RAM, so it's, I could say about 30,000 tweets at a time, maybe 40, 50, with about maybe 100,000 edges and 20,000 vertices. So the bigger the network gets, the longer the processing time is. And that's why it's nice to have automation, that you don't have to sit and wait and look at your data sets all day until it's done. We have the standard of maximum 18,000 tweets that we can get in a Twitter query. And processing that with full content and social network analysis may take about 60 minutes, 90 minutes, maybe sometimes even 2 hours. So speaking of key features, so little patience is a key feature of a NodeXL user sometimes. You've seen this overview before. So these are the 5 main key features of NodeXL. And well, here's a more detailed view. And if I go into all the details of what NodeXL can do, we'll spend another couple of hours here. So I will just focus spotlight on a couple of these key features. Mark has mentioned that well, there are different data sources. So if you have different file types in network format, like Excel files, GDF files, you can import these. And then well, we have our own importers. And well, there are also other network data sources. So every well, social media platform has an API. Do they give you network data? Well, not always, and most of the time not very good data, but Twitter is very exceptional with this regard. I'd like to point you to the Digital Methods Initiative in the University of Amsterdam. They do a lot of network analyses. They have also some network tools, and they provide network data sets. And it's always interesting to see what they are doing. So yeah, have a look at their work. And well, another data source is you yourself and your hands. So you can do manual input of data. And I will just go to show you very quickly in here. So if we enter a small social network, let's say Stan is friends with Kyle. So this is one connection. And we say show graph, and you see 2 vertices and one edge right here. And above here in the document actions graph pane, you see the graph options. So these are the basic options to control your network. Currently, the color is set of the vertices is set to black. So let's make this maybe blue. And well, the edges, well, just make this green. And yeah, let's click OK. And well, you see the colors have changed. Then where we might change the arrow size and the arrow width a bit, and also the vertex size. And then we click OK, and you see this has now changed. And we can add lots of other edges in here. So let's say Kyle is then friends with skinny, and well, and so on. You can go on for a while, and you see how it adjusts here. And if we add another couple of edges in here, which I've prepared, so with more friendship relationships, and well, obviously, well, maybe you're fans of South Park, I am. So I've populated here the spreadsheet with a couple of connections. I have full control also over the colors. On the one hand, we can control that in the basic control window that I've just shown you, but we can also populate these columns right here. We can give them color, the edges, the width can be controlled in here. We can set the visibility differently. And yeah, we define relationships. And when I now click on refresh the graph, it takes just a second. And then here you see a network of South Park, where you see, well, these are the authors, those who create South Park, and Trey Parker and Matt Stone, they give their voice to a couple of the characters. And well, if you're wondering how do I get these images in here, we can tell NodeXL to grab any image from the web. And then Twitter networks, well, we grab the profile images. But in this case, you can just go to well, South Park Wikipedia page. That's what I did. Click on the image once again, and then up here, well, you get the URL to the image, and then you can just enter that into here, and then that's how it shows up. It's very simple. So that is the manual input of data. Now let's go on to the next part. So the clustering algorithm, that's, yeah, really one of the main features of NodeXL, figuring out the clusters or groups in a network data set. And we have 3 different cluster algorithms. Most of the time we use the Claus and Newman-Moore cluster algorithm because it works very good. And all of them, they do work, but Claus and Newman-Moore tends to show a little bigger clusters. So this here is the same data set calculated with different clustering algorithms. And you see how differently these, slightly differently these networks come out. Down here, there's one small, well, not small, there's an equation. It's one of 7 equations that's behind the Claus and Moore clustering algorithms. If you're into mathematics, then it's interesting to take a closer look at this. If not, then well, I say this is really the network magic. Like the clustering algorithm does find these structures very well. And well, speaking of metrics, yeah, Mark has just touched that at the end of the session. We'll not go into any details here, but we have really a variety of network metrics, on all of these net levels. And that all gets well calculated well, pretty much pretty quickly in our graph metrics pane here. You can select which of these metrics you want to select, and then click run. One part of that, yeah, of the feature is the time series analysis. Here you see the spreadsheet and the control window right here. You can set this to hours, to days, months even, and then build some slicers for the data. So you can filter just only by mentions or retweets or whatever, and then this visual will adjust to what you click down here. Mark has shown the text analysis feature already. I will not go into any details, just to let you know that currently we have data recipes for, well, obviously English, and we have German data recipe, and we've just made one in Korean language. We're also working on a Spanish language words list, and well, hopefully in the near future we can also present that to you. The network top items part feature is part of the content analysis, and that's one big spreadsheet that collects all the top URLs, top domains, hashtags, words, word pairs, well, from the overall network, but also from the groups. So on the left, you see here the calculations for the whole network. So up here it's the URLs in the entire graph, and this is for group 1, this is for group 2, group 3. We have the domains that have been derived from the URLs, hashtags here, top words and tweet. So this is very helpful, especially for visualizing clusters and with showing what is going on in a cluster. If we show the top hashtags in a cluster or the top words, then we can, well, that makes it very or much simpler to figure out what's going on in one of these clusters. Then one major feature when we look at the visualization of networks is the autofill columns feature. And that's one window where you set different parameters for the edges, for vertices, and also for groups. And then you click autofill, and then all the columns will be automatically filled. And that saves a whole lot of time, so you don't have to do that on your own by hand. So autofill columns is very practical for visualization, and we have a couple of layout options also. So there's the entire graph layout and the group in a box layout. I'll show you that on the next slide. So sometimes it's good to have the entire graph out. Sometimes it's good to have just a group in a box layout. Usually the group in a box layout is the better choice, because then we can attach these, well, the top hashtag or top words in the groups like we have here. And the group in a box layout also has other layout options. So currently we're looking at the tree map layout with the largest group placed in the top left corner and the smallest group in the lower right corner. And then we also have layout algorithms, which will lay out the data or the net part of a network in groups. And we have several of them. Network data layouts are Vogtmann-Reingold and Harel-Cohen fast multiscale layout. And I usually use the Harel-Cohen fast multiscale layout because it gives us a very, very nice internal structure of these groups, as you see here on the left. But there are also other layout options, so you can lay them out in a circle or as a grid. So also further options that you can play around with once you have data in your NodeXL workbook. So this is then the same data set and with the entire graph out on the left. And well, that's nice to have an overview like this. But the same thing in a group in a box tree map layout is on the right. And then, well, in this case here you see the top words in the groups. And it looks different. It's the same data. We can get quicker to insights when we just create this group in a box layout. So I've mentioned there are different group in a box layouts. So the tree map layout here is on the left again, and we can also choose the force directed layout, because sometimes it's not clear what you are looking at. So currently, and on the left side, you see, oh, there are like three large groups interconnected somehow. But when we lay out this as a force directed layout, you see, there are two very different populations connected here. And in this case, it's because it's a clash of hashtags. So the same hashtag JKLive was used by an American, I think, radio station, and then at the same time by a German TV show, and that's how you get to see these. Another way to lay out your data is with a scatter plot layout. So this is what we call the influencer layout. We have the option to lay out the vertices based on the centrality metrics that we have calculated. And in this case, we have on the x-axis the between centrality and eigenvector centrality on the y-axis, and it's this combination of of metrics that helps us to find the real influencers. So it's not only between a centrality, because between a centrality may be sometimes a little misleading, because very active users or retweet bots, they gain network position just by spamming, and they have high betweens, but usually then they don't have any eigenvector centrality. And eigenvector does mean that you are well connected in a group. So your neighbors in your group are connected also to each other, and then you get high eigenvector. And in this publication here, I have the link at the end of this presentation. So this shows that in the upper right corner, then we have the potential influencers. Well, this says 2.5% of the individuals. I think it's even less. It's maybe less than 1% that are up here. And that would be another way to figure out the real influential users in the network data set. Mark has mentioned the NodeXL Graph Gallery. That's one option. Export your data set directly from NodeXL to the gallery, and you get a nice network report right here. And it's the same data as it's presented a little differently, and it's easy. I think it's sometimes easier to look at the web report than going through all your spreadsheets in the workbook to figure out what's going on. And well, we have just recently added the export to NodeXL Pro Insights, and that is a new data visualization platform based on Microsoft. There's, maybe you are familiar with Tableau, that would be competitor to Microsoft Power BI. And we can then just convert a workbook by exporting this into this very rich online report with a lot of visuals that makes it even much easier to gain insights from a network data set. And at the end of this session, we will take a look at one or more of these reports. Yeah, Mark has mentioned, the actual key feature is automation. So we have the automation window that's up here. So we load a data recipe, and then there are so many options. You see so many windows. And if you have to click everything, one by one to get to your results, then it takes way too much time. That's why we have these data recipes. And you don't need to worry about these. You can always make small changes to that. But in general, this is what you get. It's when you load a recipe, all these settings from all these options, they get loaded. And then accordingly, the data gets analyzed. Before we go further to the Twitter network, I will show you a short look about the other networks that we can produce with our importers. And last year we made big changes to our YouTube importer, which allows two basic kinds of networks. And on the one hand, you can download all comments from one video, or in this case, this is from one video. And the edges are created based on comments. So somebody comments a video, and then somebody then maybe replies to a comment, and that's how you get the network structures here. This is here in the center. That's the author of the video, and every comment that's been made that gets connected to this author. We can also gather different data sets, so not just from one video. We can say, give me the top 50 comments from the latest 50 videos that have been uploaded to YouTube on a certain topic. And then the structure looks a bit different, but you can also do that. And the second video network, the second YouTube network that we can create is a network based on video recommendations. So we can have any search term, and then we'll see what kind of results do you get. YouTube will give you like 50 But you can set it to 200 also videos, and then the crawler will get all the recommendations from those videos and create this recommendation network, which is very interesting to look at. We still need to explore this more in the future, but well, maybe hopefully you also will try to make sense out of this data. Yeah, this is YouTube. Then the Wikipedia networks well, look a little different. So we can create page networks that's based on a page link. So this right here is the what was that? The social network analysis page, and there's a web crawler that looks up all the links within an article, and well, then collects the connections to those, and that's how you get these kind of semantic clusters. We can also create user networks, well, based on the discussions around an article, or you can create well, connections based on co-authorship. And then in this case, you get this user network, so where each vertex is a user, and the connection, well, in this case, it's discussion about the social network analysis article. And last but not least, Flickr networks. I'm not sure how many people use Flickr these days. Not one of the very popular platforms, but we can also make two different kinds of networks, which are a little more limited, or even much more limited than, for example, Twitter networks. So we can create user networks based on well, comments also. Oh no, this is a typo here. This should be subscriptions, so following different accounts. So that's how you get a network that's based on Greenpeace site. And what we have the related tags network, so you can download photo tags, and co-mentions of these tags also create a network. And well, another way to create networks is, well, it's not automatically done. It's more of an advanced approach. Create a semantic network from a hashtag or from any text that you have. So in this case, I downloaded, that was last year, 1,000 tweets by real Donald Trump and 1,000 tweets by Speaker Nancy Pelosi. And well, these are then the word networks based on their tweets. All right, now on to the Twitter networks. And there are some things that you need to consider before getting data. So one thing is what's the API architecture, which means which data do you get, or maybe you not get, and what kind of network data do you get. And I will show you in a second what we can expect from Twitter, but that's something that you have to keep in mind. There's architecture that sets the limits of your data set. Then the second thing you need to think about is the query design, and that's an art of its own. How do you create a query to get the best results? And we will have a short break in a couple of minutes where you can create your own query. Then you also need to think about the tweet volume. So usually you get a maximum of 18K tweets. Well, with your machine, that quick, maybe well, the potential network size is too big. So when you think, oh, I want to have 50,000 tweets, and then well, the network size is so big that you cannot even analyze it on the content level anymore. So keeping in mind how large a network can get is also important. And well, context is always important with any Twitter data set. So which are the maybe offline events taking place that may have an impact on the data set? So if there may be just a press conference right now at what, 2 p.m. and well, you collect the data at 3 p.m. well, then there's maybe a little impact of a press conference on that data set. And if you have, well, do that like a couple of hours later, then there may be more impact about this press conference because there's more time that people can talk about it. So yeah, keeping in mind any offline events or could also be online events that may have an impact on the data set. And what very important, don't be scared. So I've heard from some attendees so that these network maps may look a little daunting sometimes, but it's just data, and well, don't be scared by it. So how do we get from tweets to networks? And the Twitter API version 2 currently has different plans, and NodeXL connects to the standard API, and that's the free version, and it has limits. There are also other plans where you have to pay a lot of money sometimes to get data. But if you're an academic, like most of you are, Twitter has just recently announced that they have they're opening their Twitter API to researchers. So that's just a couple of weeks old. So you can apply for more data, so you can access the whole history of Twitter. And yeah, that makes well, that would be important for very large scale projects. And when you get that data for free, you don't have to find other ways to get to tweets. I think it takes not too much long to get accreditation for this program, but we at the Social Media Research Foundation, we are not yet allowed to use that. This is only currently for university academics or students. Yeah, there's lots of metadata, and we'll take a look at that when we download the Twitter data in a couple of minutes. But there are also other Twitter data sources. So there are commercial providers who might have some additional metadata on sometimes on gender or occupation. I'm not sure how they get to that. But Brandwatch and Crimson Hexagon, for example, they have the kind of a copy of the Twitter archive, and they can provide data sets for commercial users. So we have 3 data importers for Twitter. So the Twitter Search Network importer has a maximum of 18,000 tweets per search. And at the same time, you cannot get tweets that are longer ago than 8 or 9 days. So you have to work with this time frame, with this plan that we have from the Twitter API. Sometimes there are reduced data volumes for trending topics. So it's not sure how much data we get. So sometimes it's 100%, 99%, could be 95%. If it's a trending topic, that the time frame gets shorter. So if you look for tweets about Super Bowl during the Super Bowl, then you get just 1 or 2 minutes, maybe, with 18,000 tweets. Probably not even. And well, the second importer that we have is the Twitter Users Network importer. That's where you can enter any Twitter username and then download the past 3,200 tweets by that user or several users. And there's no time limit on this one. It goes backwards in time, just as long as 3,200 tweets take you. For some, it's maybe just 1 or 2 weeks of tweeting. For others, it's the whole history for 10 years of Twitter. And this is, if you want to download some follower data, this is, well, the importer that makes more sense than, you could also add followers from the search network, but we say don't mix these edges. Follower data makes the network data sets very large. And, well, but if you were interested in follower data from an account, you can get that, and pretty quickly also. And the third importer that we have is the Tweet ID list network. So maybe you have done Twitter research and you have a list of tweet IDs. You can just drop them in the window here and click OK. And then our importer will hydrate these tweets to network. And there's also no time limit on this one. And so it's usually, well, the first two importers are very helpful in a combination. If you want to dig very deep into well, certain topics or certain users, then well, a combination of the first two is very good. And if you want to join data sets, you have collected lots of data before, when you can make one list with all tweet IDs, remove all duplicates, and then paste that in here, and then you get the larger data set that combines maybe several of other workbooks that you have done before. But keep in mind the size of the network that might result from that. So from tweets to networks. Well, obviously, so I think you've noticed every vertex in here is a Twitter user, and we have, well, 1, 2, 3, 4, 5, 6 different ways how they can, our users can connect. And we have the relationship tweet, which is a self loop. So when, I will show you this in a more visual way in a second. So these are the relationships that we get between the users. So for example, let's say NodeXL sends a tweet that says NodeXL is brought to you by the SMR Foundation. This is a mention. And then we have a connection between NodeXL and SMR Foundation. And then comes Mark and retweets this. And then we create a connection between Mark and the original tweeter, which is NodeXL. And also we have the edge mentions in retweets. So SMR Foundation is mentioned, and that's why we create another edge there. So, and then NodeXL Academy tweets. Today's NodeXL event will be hosted by our network experts, Wasim, Harald, and Mark. So we have 3 Twitter handles in there. That means we have 3 edges in this from just one tweet. So one from NodeXL Academy to Wasim, to Mark, and well, this is my account. And then maybe the next step is, well, Vivian says, my favorite network analysis tool is NodeXL. And see, she did not mention anybody in here. So that's why we create a self loop. So vertex 1 and vertex 2 is the same. And that's why how we get this circle right here. And then, well, NodeXL replies to this tweet at Vivian Francos. Thank you for using NodeXL. And that's how Vivian gets connected to this network. We could add, well, followers as well, but like I said, well, usually we don't want to mix these edges. We want to stick to the organic discussions based on these relationships. And well, that's how you get to a network. And like I've mentioned before, the Twitter search query design is very important. Here's are just a few examples. There's more. The link up here takes us to the official Twitter page. And down here, there's a blog post by Luca Hammer, who is also a Twitter expert, who makes a better job at explaining these operators, search operators, and Twitter. So for example, if you just want to, well, standard search would be any word you put in there. If you use quotation marks, you look for the exact phrase. So look for Tesla Autopilot, you add these quotation marks. If you're interested in Tesla analysis, but you don't want any about Nikola Tesla, just so to have from tweets about the car company, you can add the minus Nikola. So this will then skip all tweets that contain the word Nikola. You can also create a Boolean query. For example, you want to know about electric cars or electric vehicles. You say electric, and well, this is like the space here acts like an and. So the word electric should be in all of the tweets, and as the second word is either a car or vehicle. And yeah, if you want to use to look at the networks around a certain user, you add the @ sign. So this would be the official @Tesla account, and then you get only tweets that are directed at Tesla or that have been sent by Tesla. Very helpful for your analysis is the language operator. So well, sometimes there's a lot of background noise. and well, global topics that are discussed all around the world. And if you're just interested in well, English tweets, you can add the operator lang column en. You can replace that with the FR for French, the E for German, and L for Dutch. Well, Twitter defines these languages. They read the tweet and they have AI running, says, okay, it's this language, that language, and if they can figure out what it is, it's UMD, undefined. Another helpful or two helpful operators are the since and until operators. So you can define a time frame within the last 7, 8, or 9 days. So if I want to have tweets from the day before yesterday, I would have to adjust the since and the until to just match that time frame. Very interesting is list analysis, and user lists will be a part of the intermediate event. So there, well, any Twitter user can create a list, and these lists now have numbers, an ID, and we can access that list also, which is very, very helpful and very much underutilized. You can also use further filtering. So if you enter filter column links, you get only tweets that contain a URL. Or you can narrow this down to a certain domain. If you say filter, then tesla.com, for example. With these operators, and I mentioned there are a lot more of them out there, and you can build advanced queries. So, for example, if you want to do corona research, and then one way would be, so we want to see relations of corona and 5G, like Basim has shown us. Well, Basim looked at a certain hashtag. If we want to now mine data from, well, with different aspects or different combinations of words that point at corona or COVID, well, you do these, can go like this, or well, another query about corona would be then, well, Bill Gates or at Bill Gates or Gates Foundation or Gates Foundation. So you get all tweets around Bill Gates and the Gates Foundation, and then you can add the same words well, to that. And in this case, then well, you get some interesting data about well, probably many conspiracy theorists also mentioning Bill Gates. Well, here are also 2 examples. So we do a weekly network map for the Global Investigative Journalism Network. So they just want to have exactly one week of data, and they want to figure out what has been, well, what new articles with data-driven journalism have been put out in the last week, and then they create the top 10 DDJ, that's data-driven journalism, links or articles in their weekly newsletter. So what I would like you to do now, well, not just a second. So here's an overview. If you of the search terms for Tesla, and if you just make small changes, so the Tesla itself, or make @Tesla or #Tesla, you get different outcomes. These data sets have been pulled at the exact same time, 18K tweets. And this is the most general one. And then 18K tweets give us about 10 hours of data. If we add the @ then we get 2.5 days of data. And if we have #Tesla, then we even get to 3.5 days of data. And so I would like you now to build your own query. I give you like 3-4 minutes. Now you go onto Twitter. Well, you can keep these in mind or look at this to build now your own query. So that would be just like this. So this is the corona query. Well, you can copy and paste the advanced query from the slide deck here, or you can just now create your own query, and that's what we'll use then to download the data and and visualize this. I give you now, let's say, 3 minutes. And well, if you have questions about the querying, well, put them in the chat. And yeah, I will stay silent for 2 or 3 minutes, and I will show you then. I will use the hashtag dataviz for further for the data collection in a second. And it's very helpful to sort these by latest, and then to see, you can see our last tweet was 9 minutes ago, 11 minutes ago, and from this you can already tell how much traffic is in there. Yeah, just now pick your own query, test it here, and when you are done, enter it in the Twitter search network importer. So you open that one right here, import Twitter search network. And it's now very important, if you want to follow this step-by-step protocol that I will show you, then you should well be, or let me start over. I will go through the steps now when step by step, but if you cannot follow, that's no problem, because we have this tutorial also available on the web. So yeah, I will now stay silent for a couple of for 2 minutes, and when you enter your query in here, then click OK and make sure to limit the number of tweets right here to 1,000 or maybe 500, and that speeds up the whole process. And then when you click OK and wait, it should take like 4 or 5 minutes. Okay, now when you have clicked OK, then you'll see at the bottom it will collect the data, and you just have to be a little patient. And while this data gets pulled, I will continue with my presentation for a couple of slides, and then we look at the raw data that has been downloaded. Well, it is the search network for just Tesla. It's already a little older, but you see, if you compare these networks, if you create them at different times, these shapes, they are different. There are new actors coming in. Well, for example, up here, this is one very popular tweet that's not connected to any other part of the network, but that's gone in the next analysis. But usually there's one group there where the Tesla account is in the center. Here it's in group 3, and here it is in also in group 3, and also here. Oh, this is all in group 3. Interesting. but it will not automatically show up in group 3 all the time. Sometimes it's in group 2 or in group 1. And yeah, creating like a time series of these analysis, we have something to compare for your project. That would be a good approach. So if you create data sets once a week and you have you cover 4 weeks, then you have a lot of data that you can analyze and then compare. This is what it would look like for the search term at Tesla. Also, see shapes are constantly changing. And well, here's an example from a German talk show. So well, every talk show in the world now has a hashtag. And well, if you want to analyze the hashtag, then you might get to a nice overall network. But then you can take a close look at the timing of these tweets, and you can zoom in into the live data. So what has been tweeted during the TV show, and then this is the subset of this one. So these are all the tweets that were sent within 1 hour of the TV show. This is an example of viral content. So that was an article on a Swiss platform. So this guy is apparently responsible for the algorithms that have been used by Cambridge Analytica. And this article came out just shortly after the election in 2016 in the US. And well, this guy did an interview and said, oh, I just showed them that there's the bomb is there. And so this went viral, and you see many different sources have mentioned this article. So I used the URL of the article to get to this network, and this is what a viral network does or can look like. You have many sources of users who start their own discussions, who have their own small communities. Here's a little advanced technique, not that complicated, but we can visualize the sentiments based on the count of words, positive minus negative words, and then where we see, well, we get an impression of the sentiment in the data set, and this is based on hashtag fleets. So that was a new Twitter feature that was introduced a couple of weeks ago, and people all over Twitter, they were like, oh, what the heck is this? This is so stupid, we don't need this. And you see very easily here that it's a lot of red and negative sentiment towards the Twitter fleets. Well, this, for example, is another map for Tesla. And so here we have a very red group up here. And you can already tell from the hashtags in that group that these people are not happy. So Tesla quality issues, Tesla parts issues, the sociopathic business model, losers, fraud formula. So this is the group that's not happy. And we're visualizing this by sentiment with the coloring of the vertices will point you quickly to that. Otherwise, if you don't use this coloring, you would figure this out anyways, just based on these hashtags that have been used. All right, now it's time for the hands-on tutorial. You should now have your data set, and well, I have prepared this already. So this is 1,000 tweets that I've downloaded on the hashtag DataViz. And before we do anything, scroll a bit to the right, and there we see the metadata that has been collected, or well, actually it's part of this is metadata and some of this is content data. So here we have the relationship and the relationship date. Here's the tweet text, and from this tweet column, the URLs in the tweet get extracted, the domains from that URL gets extracted, and also well, the hashtags. And if there's a media link in there, you get the media link. Here's a link to the tweet itself. Well, this is the tweet date. So there's really lots of stuff in here For example, if we go further to the right, well, here we have the language column. The retweet count is here. Favorite count also, but I cannot go into much detail here. If you go to the vertices spreadsheet, then there you see all the metadata that's collected, has been collected around the users. So, for example, we have the user ID, username, follower accounts, how many users are followed, how many followers are there, how many tweets have ever been sent, how many favorites have been sent also. Here we have the self-description of the users, the location also. It's also self-descriptive descriptive location. And well, this is the metadata. And if we now want to start our analysis, we want to prepare. Now up here is the option data, prepare, and we have the count and merge duplicate edges. And we don't want to merge these right now because then we lose some data. So if we just click count and merge duplicate edges and insert the counts into an edge weight column, and click OK. And then in the edges spreadsheet, you see a new column has been added. And here is edge weight. And if we can now sort this from largest to smallest, see that, well, this floodbot has connected to StratAI in 8 edges. So, and this is 7 edges and so on. So this is, well, one metric that we use to visualize the connections of coloring and sizing of these edges. And then, well, after the preparation step, we then cluster this data. And up here in analysis groups, we have, well, group by cluster. I say Claude Moore, and I put all neighborless vertices into one group. So make a check mark there. I now click OK, and well, that was quick. You see now there is a new spreadsheet that has been populated, and you see, well, there have been, well, more than 111 groups that have been found. We have another spreadsheet that shows which user is in which group. And now we can go to the next step and we'll calculate some metrics. Metrics calculation is up here, analysis, graph metrics. And if you cannot follow me right now, that's really no problem. It's just for you to get a basic understanding what steps are performed during the automation that I will show you in a bit. So let's just select here everything up to group metrics, and then we'll click calculate. And this may take maybe half a minute or a minute. Oh, already done. And here we have the overall metrics spreadsheet that has been populated. And that's where you get the overview. So we have 844 users in this network. Number of edges is here. Well, some of the basic metrics around the network. We have density, modularity, for example. And also we now have in a vertices spreadsheet, vertex metrics. Here we go. That has just been calculated in the last step. So in degree, out degree, everything that I've selected is now in here. And then we can sort by betweenness and see, well, who is now well, most between user, and does not need many connections because right now we have a small data set, and now this is not really an influential user, because if we combine, well, betweener centrality, we could also look at eigenvector, but in degree, out degree is also interesting. So in this case, this guy connected, well, to one other user and to 9 other users here, and only one other user connected to this person, while the person in second position here has an in degree of 73, and that's probably a trending tweet or something. So this is, well, the metrics calculations. And now if we want to do a time series analysis, we go to graph metrics. We deselect everything and say time series, click on options. And so we just point to the date column. That's the relationship date. And that column will then be analyzed by days. Let's just pick hours. We want to create unique edges by imported ID because well, one tweet can have several edges. In this case, if we select this, we only know we will know how many tweets overall there are. Let's get the slicers. I click OK and then calculate. And well, here you get the time series data. Click this away. You can scroll down to the bottom, and well, here you see the overall number of tweets. Even though I collected 1,000, so this is the number of edges, I think. Could be a small bug in this data set. But this is how you create the time series analysis. Next is then in graph metrics. Let's deselect this and word pairs options. And so we want to count by group. We have to tell again, so which is the column where the text is, and we can analyze then the tweet. But we could also run the analysis just on the vertices spreadsheet and on the description of the users. That's also possible. But in this case, we want to know what's going on in the tweets. And then I can just click OK and calculate metrics. And this will take another few seconds. And then we will see that there are even more new spreadsheets that get calculated. So, yeah. Yeah, it might take another couple of seconds. Okay, while this is running. Okay. No, it's something is happening. Oh, here we go. There is then the spreadsheet for words. You see words and word pairs. So this is the overall count of words by sentiment list. This is top word, and this is the top words, which also includes the hashtags. Right here, lots of hashtags at the top. And well, here we have the word pairs that have been calculated also. And well, if you now also take a look at the edges, vertices, or group spreadsheet and go all the way to the right, and you see that further columns have been added. So this is a count of there are 2 words in this tweet, in this edge that are in list 1. That's the word percentage, and we have 1 word that's on the other list. And well, this gets summed up on the vertices spreadsheet. That's the same count in here. So this user has 5 positive words, 3 negative. Yeah, and the same also gets calculated for the groups page. So all the way on the right, again, we see the same columns. And those have been added just with the last step. Now we will analyze the network top items. We deselect this. Well, there are 2 ways to calculate it. The simpler way is this one here, Twitter search network top items. It says for a while now old to be removed soon. I don't think we will remove it that soon or ever. But this is the simple version of the network top items that you can also define the other option down here. But for our purpose, this is just fine. I will click, yeah, calculate metrics. And this is also a step that will take 1 or 2 minutes. And if this is, well, like a 20K or 18K data set, well, it will take maybe 10, 12 minutes or so. And while this is running, I think I can go to our presentation here. So when we're done with this step by step, then we go to the automation of NodeXL Pro, and I will show you how to do that. So is it maybe? Oh, it's done already. So a new spreadsheet has been created, and here it is. I've shown you that before. This is the top item spreadsheet with the entire graph count. And then if you go further to the right, you can then zoom into groups, top URLs in each group. Okay, and those are the network top items. Now we can go on to autofill columns. Up here, you click on autofill columns, and then let's say we want to give the sizing of the vertices. We want to do that by betweenness centrality. Yeah, we want to do the edge color by edge weight, and that's down here. And we do the same thing for, well, let's say this. So let's define edge color. So if the edge weight is low, then let's pick rather gray. Okay, and make this red if there's a stronger connection. And we can ignore outliers also. I use logarithmic mapping. Click OK, and we say the edge width from 1 to 10, also ignore outliers, and the opacity. Yeah, the opacity is a little complicated at the beginning, but when lots of edges going or laying on top of each other, then this is very, very helpful. So let's make this from 50 to 20, and let's say OK. And in the groups here, we can now set that we can pick the top items that we've just created. So let's show the top top words and tweets. Well, this is OK for now. And now I click autofill. And yeah, you see, oh, something has happened here. I close this. This still looks a bit weird. So here we have the auto scale that has been used. So you see something going on. Let's just switch this to hardcore and say layout again. And this then looks again a little different. Oh, you know what? I forgot in autofill columns, set the size properly. So between this shape option, so no, that's wrong. I picked the wrong one here, sorry. So vertex size. So this is between the centrality, and then size options. We make this from 50 to 1000. So that's how we then get the right proportions in this network. And here we go. Zoom out again. And well, currently we are looking at the entire graph layout. We can now go to up here and look for the layout options. Those are also available from up here. So that's the same shortcut. And this is currently set to the entire graph layout. I want to now set this to lay out each of the graphs groups into its own box and choose a tree map layout. And yeah, that should do it. I say OK and just lay out again. And here we go. Now we have the group in a box layout. And you see now that the labels are a little too big, and we can adjust this out for graph options. Other labels. So this opens up well, new options box, and now well, here are the group box labels, and let's say we want to have this in at the top left. And well, we don't want any edge labels in here, that gets messy, and vertex labels, well, you want to have them as well. So okay. Oh, and then, well, the label is still a little big, and let's make it smaller. So font size 9. Click OK. And here we go. Yeah, now the analysis is almost done, but you see now we only have these circles. We can now bring in images from the basic controls here. We set this to image and click OK. And now I click refresh. And did I do something wrong here? All of the columns, just a second. I think I messed this up before. Close. Yeah, and now it takes a little while. So when you're working with Twitter networks, pulling in all the images is one of the longest steps in the visualization. If you refresh a graph with images, then it will pull the URLs again from Twitter, and that's why this step takes a little longer. But with 1,000 users, or not even 1,000 users, 800, I think it was, that's maybe 1 or 2 minutes again. And I think I might have set one option a little wrong, but let's see. So we have the group options. So we can tell NodeXL to pull colors and shapes from the different spreadsheets. So currently we get the group colors from the group spreadsheet and the shapes also, but we want to have to set this to the shapes that have been specified in the vertices spreadsheet. I know this is a bit complicated, but when you do a couple of these analysis, then you know how to navigate and well, know what to look for and what to do. I just made a small mistake by not setting that group option before refreshing. Now we'll give it another couple of seconds, and then it should be done. So how are we doing in terms of our time right now? I think Wasim, are we supposed to have the next break in a couple of minutes?
Yep. So in the schedule we have a break, I believe. So we could break here.
Okay. Yeah. So I will wrap this up within the next 2 minutes. Okay, you now see that the images have been pulled. You can zoom in, zoom out, and what we can now do is we create a network map by right-clicking, save image to file, with the image options, where we can define well the size. So this is make this maybe 5,000 times 4,000 pixels. Preserve aspect ratio. Okay, I'll go like this. Okay, and now I say save file, save image, and NodeXL. So we call this the data viz. So that's done quickly. Now here is the image, and this is now a very large map where you can quickly zoom in and out. So currently we don't have the vertex names in there. We can add these obviously. So now you can navigate through your network map. And yeah, this is the end of the tutorial step-by-step Twitter network analysis. I think maybe just before the break, I should show you how automation works, or no, we do that right after the break. I'd say, well, now we wait until, well, it's 5 p.m., close to 5 p.m. in Germany. So yeah, let's continue in 15 minutes. Thank you for your attention. See you in a couple of minutes.
Yep. So we can break here for about 15 minutes, and then we'll join back.
All right. Okay, I think, I hope you're all back, and then we can continue with automation of NodeXL Pro. And yeah, so like I mentioned before, so if automation doesn't work for you, if you have wrong settings, then something is very wrong. So NodeXL Pro should run smoothly from import to export without any extra touching of the of NodeXL. And in the Google Drive folder that I've shared in the beginning, there you have a zip file with the options files. These are the data recipes. They are also available on our website. So we have the page about automation, and those recipes are also linked right here. And now, what do these recipes do? We have, just a second, so automation. Well, from this page, you can go to Twitter data recipes, YouTube, Wikipedia, and then let's just now look at the Twitter data recipes. I think I have 3 or 4 in this recipe bundle, and well, you can import any of these. They have slightly different outcomes. They all do social network analysis and content analysis, but sometimes when things get very large, for example, then you might want to have some settings that you don't show a vertex label for every vertex, only for the important ones, or you want to shapes, so which makes it also much quicker. So you show only the interesting ones with an image, and all the other ones, they will just show a disk or whatever. So this would be the third recipe. And what here's also one with an alternative layout. We're just showing how different what a network can look. You can choose any one of these. So once you have downloaded the options file, and then you unzip this to your machine, and let's save it to your machine. Okay, here's how we do it. Options. This is the section where we import this options file. Now here's import, and then you navigate to the folder where you've just put your put that recipe bundle. And this is 2020-21, so you should see this. And there is standard recipe, and if you just click on the Twitter user network 1 and click open, then you see, nothing really happens, but I've shown you all these settings, all these options files. They have now all been set. Now we have to go to data, import options. So here we can set a check mark that the automation will start right after the data comes in. If you want to have a look at the raw data first, uncheck this. If you want to have this run smoothly, click on that. And here is a small arrow, click on that. And this is the automation window. And now we want to tell the recipe where our files get stored. And this is this option here, save workbook to a new file. If I click on this, it gets unchecked. So I have to click it again. And now I click on options. And now you have the Explorer, and then you will navigate to the place where you want to store your data. So this is my NodeXL file folder. Let's point in at that. And I click OK. Then, the image, we want to save the file to the image also. And what I want to do also now is then export this to NodeXL Graph Gallery. And these are my settings and my password for the gallery. And I click OK. 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 And now, it's customized, but it's not yet saved. So I suggest you now export this option settings again, And well, you can just save it to the same recipe. But this just means that it recognizes the file location where you want to save the files. And if I just say, well, OK, or overwrite this, I now just open the importer, Twitter search network. I'll do, well, hashtag dataviz again. I will just do, well, this time I will pick 2000. And now I click OK, and this would be now the time where you would now do something else. Standing by and watching what's happening might not be that interesting, but clearly you see how these pages are pulled. So each of these pages has 100 tweets. This goes up to 20, maybe 21 if there are missing tweets in there. Yeah, here we go. And now, well, NodeXL will convert the data set. And we now leave it like this and just wait. And while that's running, I will continue with my presentation and we'll talk to you about the Twitter users network importer. So that's the other importer that's very helpful, where you can collect 3,200 tweets by user. And well, these are, well, the basic setups. So if you enter a list of 100 Twitter handles in here, and you only want to find connections between these 100, you keep this option, import only the Twitter users I'm interested in. So if there's 100 users in there, the overall network would have exactly 100 users. If you uncheck this, then everyone who's mentioned in these tweets or gets retweeted, well, that gets pulled in, and so you get the full network. Most of the time, well, you should start with the full network, because you can also narrow it down to the internal network later. But that's up to you and to your research interest and your method. And this is what this would then look like. So this is data that I've been doing about the German Bundestag from the members of the German parliament. Everybody with a seat in the parliament, and this is the internal view. This is how the politicians talk to each other within the parliament, and this is the full network of all Twitter users that are embedded in these networks. We can use this importer to create ego network analysis. So here's an example of Elon Musk. I used to do this with Donald Trump for the past couple of years, and I'm happy now that he's gone and we can now look at other users. So Elon Musk was one of the big stars on Twitter. There's probably not many people who can manipulate the Wall Street shares with just one tweet. So it's interesting to look at what he tweets. And when we open the Twitter importer, you just enter the single user account in there. And well, you download 3,200 tweets and make sure this is unchecked. If this is checked, then there will be just Elon Musk in the center and no connections at all. And well, here you see then, well, regular layout. Here's Elon Musk in the middle. And when we look at the edges spreadsheet and use count and merge duplicate edges, then we get the edge list. So who does Elon Musk connect to when he's tweeting? Well, out of 3,200 tweets, 509 times he did not mention anybody else, but well, he speaks a lot to well, SpaceX, Falcon Heavy. Well, there are lots of yeah, let's say space-related, outer space-related accounts in here. So even more than Tesla itself. So this is then the connection weight of all the users that Elon Musk connects to. This is the time series analysis. So we see that, well, in June he was, July he had more than 400 tweets per month, but around about 200, 250 each month. You can also choose a different layout. This is a scatter plot layout. So with based on followers and following, and well, Elon Musk has most followers. He's right here. So this is just not just playing around, but this is another option that you have. Well, to not just lay it out like this. There are many layout options. So and one could be this one. And well, after we've pulled these 3,200 raw tweets from Elon Musk, then we can use the feature find and import missing tweets, because you see here with these 3,200 tweets, Elon Musk is always in vertex 1. There's no other user in vertex 1. But if we now find and import missing tweets, that means that if Elon Musk replies to somebody, then the original tweet he replied to from another user gets pulled in. And also if you retweet somebody else, then the original tweets gets pulled in. And this way, yeah, you see that after the analysis there, we see clusters of with 2 major clusters besides his central cluster. And this one is then, we can very quickly say, see, this is the Tesla group. And this is then the SpaceX Starship Falcon Heavy group. This is also Tesla. But this is how you find out, well, how connected a user is in his communities that he talks to. So this is, well, part of the ego network analysis that we can pull. And well, another way is now looking at Twitter data, and I've made this follower data, follower data. This is the setup to get follower data just for our Twitter and NodeXL Academy. And it's important to, in this case, select this section here, which will add the followers. This then should be set to actually 0, but we must download one tweet by NodeXL Academy. But we want to have the followers, and it's below 2,000, so we can keep it like this. And yeah, here's the result. It's the grid layout, and I've used well, several settings in here. So what's going on is, well, the shape is based on a reciprocated vertex pair. So if there's a mutual relationship, if a connection is reciprocated, then well, we see the image. Otherwise, we just see the circle, the disk. And well, tooltips is, well, in the layout order is by followers. So the users with the most followers is down here, and with the least followers down here. And the size of the vertices is based on the number of tweets. So, for example, someone here has lots of very few tweets, but lots of followers, for example. But this is not a mutual relationship. This might help to investigate a user account. Okay, this is an old slides, 2 old slides from past year. And so one other approach is the ego network analysis 2.0, and well, ego, the word ego fits very well with this person. So in this case, I want to download I downloaded who was followed by Donald Trump, just 46 users. So I enter the username up here. And down here, I just limit to 46 because I really don't want to download 53 million followers because that, yeah, would take forever, and Excel stops at 1 million rows. So we only want these 46. And when we get these 46, we also get 46 of the followers. But then when we have pulled these, then we can add these 46 into the users network importer again, and here they are, and then collect 100 tweets by each of them, and then we get the network map, well, which is based on the tweets that Donald Trump saw when he logged into Twitter. I did one for Joe Biden 2 weeks ago. I need to update this, but it's interesting here to see well, how pretty much everybody in Donald Trump's own well, follower network will use the word Trump. So he read his name a lot. So that's the main takeaway here. So that's another approach to dig deeper into just one single account. Here is now an example of a bot network that I've discovered, what was 3-4 years ago already, and I just made an a map on hashtag NetGas, and I saw there's something wrong maybe with the APIs. I didn't know what it was, but there are lots of users here who don't have an image. And I thought, oh, that's suspicious. So I used the users network importer and run the internal network analysis to see if these users that I found down here, if they are connecting to each other. But they did not. But they pointed to a lot of really bogus websites right here, and using hashtags like Trump, crude oil, NetGas, healthcare. So we're using kind of popular hashtags and we're spamming the space. And when we look at the full network, so who do they connect to in general, then there was another pattern. So they don't connect to any other users that are mentioned in their tweets. So there are very few overlaps. So here are 3 users. They maybe connect to 1 or 2 in the center, but mostly all of them, most of them, they just have one single group, and no connections, no edges go to other groups. No cross connections. Maybe one, but that's a setup of the inventor of this bot network, and I couldn't do much more analysis because Twitter removed these accounts, so they have their own algorithms to figure out if there is a bot network going on. And these technologies, they get better and better, and it gets harder and harder to spot these bot networks. But if you run into one, make a list of these usernames and run them through the users network importer. Here's another bot network where NodeXL is up in the middle. So we saw these tweets lots of time last year, so not anymore. But there were hundreds of tweets in a month, and they all were slightly different than this one. They added a couple of 1 or 2 words or different hashtags, but it all looked the same, just to get around these AI algorithms from Twitter that would figure out, okay, this is all copied and pasted. No, they make it slightly different to get around these methods by Twitter. And well, as it turned out, after looking at users, I found like 10, 12 Twitter handles that are somehow connected, and what you see, it all goes down here to one user, and that is Mike Quindasi. It's a real person. He is an influencer on many hashtags, and one reason why he's an influencer is because he has a good bot network set up that amplifies his accounts. But in general, he has some interesting content as well. But my conclusion is, 99% Mike Quindasi set up this network, even though I cannot have 100% proof, but who benefits? It's Mike Quindasi. So that's how we can figure out what's going on or what's the purpose of such a bot network. We can also work with some advanced technique. It's not that complicated, but we can create multimodal networks from Twitter data. So we have the column media, and we can copy and paste all the links to the images into the vertex 2 column. And then we have a connection from the person who tweeted. So in this case, this person, this down here, these are the tweeters. And then here are all the images, and they all look the same, but these are individual new images every time. So you see there's something really odd going on in this case. So similar images post all over. And another piece of proof that we're looking at a bot network. This is another user media network. Well, it was about hashtag Tesla. So here we have one user who keeps posting tweets, images around Elon Musk and Tesla that all look the same. This is also another level of analysis that might be interesting to look at. But this is not done very simply. It takes like, I'd say 5 to 10 minutes to work on a data set to get to this. But that's, I think, one for the intermediate or for the advanced class that we have in the future. You can also conduct cross-platform analysis. Vasim has mentioned that he used queries around YouTube that were shared with the 5G topic. So this is also a query that was made in 2018, looking for all YouTube links that connect to Jair Bolsonaro, the president of Brazil. And yeah, and then we connect, we put all the URLs from YouTube into Vertex 2, and then you see how the users cluster around certain videos. Same thing can be done also for Facebook. This took much longer to clean the data. So the query was with facebook.com or fb.com or fbme. And then I looked at all the connected URLs to Facebook and extracted just the name of these groups. And well, this is then another layer of interesting data that you can create. Well, semantic networks, well, we had that before. So I'd like to make some remarks about how to find insights in these data sets. So there's really no magic key, and I suggest please don't get lost in the data, because you can spend a lot of time with just a single data set. And there are several levels of analysis. So you maybe just only look at the network graph from a visual perspective to see the shape. But you can connect your analysis well then to the table. So you look at the graph and then go to the table, click on the table, highlight something on the graph, or you just look only at the data that you have in the table. So it's these levels that you can connect. And the basic questions that we have is, well, what is the overall shape of the network? Mark has shown the Pew report, so that helps to identify what's going on. And then also we look into the clusters. What is the shape of a cluster? Is this a wagon wheel or in-hub and spoke network? Or is it more like a community? So from the shape, we can tell a lot. And then I think actually the main question is what social network analysis, why is a group clustered in this certain way? So the algorithm has found something, and then you need to figure out, okay, why did the algorithm cluster it like this? And yeah, and to answer this question, you look, who is influential in a group? Is it just one, is there a hierarchy, just one very influential person with high betweenness and everybody else is low betweenness, maybe not that important? Or is it more like an even distribution of betweenness, which points more at community clusters? And then also you can go down to the tweet level and to see, well, filter out some certain tweets or trending tweets. And well, those are the basics of a network. It's based on tweets, and so figuring out, well, what is it then all about? And then also, we're comparing over time. You should create a certain amount of analysis in a row, so you have something to compare, and you see changing patterns, but some are reoccurring. And if the same users show up as influencers every time, then you can make the assumption that which person will show up as an influencer in the next time. You can pretty much predict the outcome of the next analysis. Yes, and well, from a practical point of view, if you look at the workbooks, you can sort the vertices table by betweenness centrality and then go to the vertex group on the far right. And select just that group to narrow down the analysis. So if you want to know what a group is about, then select this, just only this vertex group from the vertices table. You can also do the same thing in edges table. So if you look at group 1, you sort by the retweets or favorites column, and then only look at users that are in a certain group, and that helps you to get to more results. You can also set the visibility of certain groups to skip, and if those are skipped, then the one you show gets larger and laid out in a big way, which may also help to find structures. I don't do that often, but sometimes it's helpful. And well, also from the network graph, you can always hover over a user and right-click. Well, I should probably show that right here. And okay, this is the automation that has been finished while I was talking. And yeah, if here just hover over a mouse with the mouse over a user, and you see the user name and the last tweets by that user in the data set. If you right click on a user and there's open Twitter page for this person, click on that, and then you're taken right to that profile of that user. Yes, so I will wrap this up in the next couple of minutes and hand this over to Mark. I'll just show you a project that I've been working on for a couple of years, now 2 or 3 years, I think. So I've mentioned the German Bundestag analysis, and well, this is the summary of my findings. And I've presented this last year. That there's a video, 15-minute video on YouTube on this, if you want to take a closer look at that. So what I'm most interested in here, the general research question is, what can we learn when applying social network and content analysis to tweets from politicians in a parliament? And in the German Bundestag, there are 77% of all members, they have a Twitter account, and that's really quite a lot, and gives us very, very good, interesting data to look at. Yeah, and one major sub question is, how does party affiliation align with network clustering? And well, this is the result. So I colored the users by party. So everything that's colored here is a member of a party. Everything that's gray, that's a user outside of the Bundestag. And then it's interesting to see, oh, there are 3 parties clustered in this group. Well, why is that? It's the right-wing AfD party, it's the governing party, and the liberals. And well, these shapes, they also change over time. Well, here is an overview of the internal and external network. And well, if you take a close look, you see that there are different coalitions. For example, here on the right, or here in the middle, black and yellow in one cluster from the full network, but black and red in the internal network. And well, similar things happen all the time. And well, I don't have the time now to talk about the details of this, but this approach can be used for any parliament in the world. So if you want to do this analysis, this kind of analysis, I can guide you through this. It's not as complicated as it looks, because I make one monthly data set each month, and so this is the full network, and from that I can filter the data to certain aspects. For example, in the full network, I create an internal network. From that, I can look at the cross-party network, so to look only at tweets where a member of the parliament mentions another member from another party. So this is the cross-party network. And from this, then we can derive the party interaction network. So these are the networks by reach. We can build subnetworks for each party to see what they look like, or we can networks by relationship, just only the retweet network. And that's and the retweet network is, usually retweets are in agreements by the politicians, and the clusters come out very clearly when it comes to retweeting. The mentions and reply network look different. Further, we can look at networks by topic, so we can filter the data set by just one hashtag or just one word that was used. So how are they talking about Corona or whatever? And also we can then create networks by edge weights. So we skip edge weights that are low. So in this case, well, this shows all edge weights, even with low connections, with just one single connection. And this one here is then with 2 or more connections between the users. This is 4 or more and 8 or more. And well, this gets more and more sparse. And well, if you use this approach, then the cluster, the party cluster alignment is also similar to the retweet network. Yeah, to wrap this up, well, this is what I've copied from the sentiment analysis. So very interesting to see then the governing parties, they use positive sound, positive tone, and while the opposition parties are negative, I guess that's what they do. Government praises what they are doing themselves, and where the opposition has to be critical of that. And this is shown in this data. Yeah, so that's it. These are influencers, and I think that's it. Now I can pass this on to Mark. Just one thing, there are 2 or 3 nice tools here. So Luca Hammer account analysis has nothing to do with networks, but you can get a very nice overview of any user very quickly. So if you sign in here and you want to get quick overview, so this is, well, this is mine. So what's that, Joe Biden, what did he do? So very quick summary of the data. And well, we also have a similar thing. Oh, and it's something that I forgot now to show you. It is the, what's going on here? Export to NodeXL Pro Insights. I have shared a link in our chat before. And this is now the one of the reports. So this is a report that I've shared with you. And well, there's a very rich set of visuals and analytical pages that all are dedicated to certain aspects. So this is the overview page. You see how users connect to the mentioned tweet authors, connect to the mentioned users. And this is all usually yeah, interactive. So we click on one user, the most active user, then we see this all adjusts. All right, let's go to the location page. So it's always interesting to look at. On the right, you see the groups that have been found by the network analysis. These are the size, relative size of the groups by number of tweets. And well, if we now click on just one group, we see, oh, the group 2, yeah, it's a global group. Well, let's click on, how about Spanish? So this is group 5 mostly. I click on group 5, and here you go. You see then this is mostly Spanish cluster, group 5. There's so many other things. I could spend another 2 hours with this, so maybe one more page. It's the hashtag cloud on this you know, of this data set. Well, the page only has tweets that contain a hashtag. The same thing is also available for words. You can take a look at the top tweets right here. You can zoom into any group. What are the top 3 tweets in group 4, or pre-sorted. And well, one more. Sorry, Mark. Actually, 2 more. The media page. All the media can be shown in here. So, and all, well, that all it also adjusts what's going on group 18, just one image. What is in group 3? Well, you see some similar images also. And well, group 3, most active user is the Center for Disease Control. Yeah, and so you can now spend hours with just one report figuring out the insights of a network data set. And now finally, the last one, we can compare also two pages. We can, well, for example, just select group 1 on the left, and then we use the control button and click on group 2 on the right, and then you can now compare these groups. That's also possible on the with four indicators. So you can say 4 groups or for users, different hashtags, whatever. So just to compare, let's look at 2. This is 3, 4, and 5. And yeah, we are very happy about this product. It makes our work much easier, much more fun than clicking 100 times through a workbook. So yeah, this is our latest product. It is available already, but we're in a soft release stage. Yeah, but it's working all right. And well, I think just very shortly we will really will start our marketing campaigns in a big way to promote this product. Okay, then now I pass this on to Mark. Thank you for your attention.
Nice job, Harold. Appreciate it. Yeah. Let's see. Let's just pause for a moment here and see if there are any questions that people would like to bring up via video rather than the chat. I will note that I have just added a link to the chat. There are quite a few links in the chat. And I think I'll make a request to Wasim. Let's make sure that we copy the chat before we close out the Zoom. The last link in the chat is to sign up for our newsletter. If you stayed this long, you might want more. So come and get our newsletter. And you get updates about all of our newest releases, including things like the very new availability of NodeXL Pro Insights. Okay, so I think this is my opportunity to sort of do the big wrap up. Is that correct, Wasim? I now sort of offer an overview, I think, and some closure.
Yep. So we've got a summary scheduled in now, and then after that Q&A. So I've recorded some questions in a document I can put to you and Harold after your summary as well.
So I'll just wrap up with a little overview closure, and then we'll go to Q&A. So our aspiration is to make it easy for you to spend your time telling stories about the pictures rather than making the picture. And this is a shift in where the analyst spends his or her time towards the analytic, the narrative, the interpretive. And so we're going to get data, put it somewhere, analyze it, visualize it, and publish it from a variety of network data sources. And that could be Flickr or YouTube and wikis, and not Facebook anymore, but that wasn't us. And then we're going to store it for you and make it so that you can directly manipulate your data, because it's not in a database, it's in a spreadsheet. And there's a very good chance that you can kind of get in there and manipulate that data. But we're also going to analyze the data in an automatic way. We're going to grind the data. You know, you bring us wheat, we're going to give you flour, and we're going to perform most of the basic network analysis operations, and then draw the picture, and then publish the picture, either into the graph gallery, or as you've just seen, our latest and our greatest, NodeXL Pro Insights, which really highlights our focus, our philosophy that says we should be more focused on discovery and communication than on the mechanical process of collection, analysis, visualization. That should be quick. The rest should be, well, you know, what is it that the steam-powered machine couldn't do? It didn't know where to go, right? So there are some things that the humans know how to do better
than the machines, and we should focus on that. And so the machines can reveal for us who the key people are, what the divisions are, what the connections across the divisions are, if they exist. And this has enabled a lot of research where people are now able to look at topics in social media in a systematic, empirical, quantifiable, repeatable, and shareable way. And so what we are about is the recognition that networks are everywhere. Once you start to look for them, you'll find them. And you start to worry, why didn't I notice the network before all of this? And in some ways, we are in an era today that's similar to the time before Google Maps. Can anybody remember the time before Google Maps? I can. I have a lot of gray in the spirit, so I can remember the time before Google Maps. But Google Maps lets us do three things really easily. It answers three questions for us. And I believe those questions are, where am I now? Where do I want to be? And how do I get there? And what we are trying to communicate is the idea that there is a analogous set of three questions that could be thought of as sort of Google Maps for the social layer rather than the geographic layer. It's where am I in my network? Who's in my network in a position that I kind of wish I was in that position? And how do I get from here to there? And once you realize you are in a network, you might start to want to know where you are in your network. And it also turns out that some of the shapes of these networks are better for some purposes than others. And so not only do certain shapes perform better than others, but certain positions within those shapes are better positions to be in. And so our Pew report says that there are 6 basic types of shapes that you're going to encounter in social media of a sort, and that would be the type Twitter, email, discussion board. It has to be, I can reply to you. So that's a critical caveat. And so these 6 types reveal that some conversations are divided. They're polarized, 2 groups of people who won't talk to each other. And some of them are unified. They're a community. Others are completely fragmented. They're like a bus station. They're a brand. Others are bus stations with a little bit of clustering. They are sort of news of the day. And then there's broadcast and support, the in hub and spoke and the out hub and spoke. Here's people talking about American politics. They don't agree. They don't want to talk to each other. These are people talking about managing communities. They all like each other. They all talk to each other. And there is no one of them that is the big celebrity that everybody's huddled around. They're just all talking to each other. This is a brand. Nobody's talking to anybody. This is news of the day. A lot of people are not talking to each other, but some people are listening to news outlets. This is being famous. I tweet, a lot of people retweeted me. And this is trying to do customer service. You complained about the product and I'm trying to get you to stop. Well, I'm trying to pretend that I'm Dell and I care and I listen. And so, oh yeah, I should point out, these are the remarkably attractive people who wrote volume 1. And I really should update this because there's volume 2 and there's also Itai Himmelboim, who is another co-author. And the 3rd volume, it's going to be Wasim, I'm pretty sure. Wasim's coming in for volume 3. And Harold too. So that, again, this is our data flow. This is sort of like get photons, let them hit the detection layer, adjust for noise, display the image, print the photo, sort of. And so we want to help you find the key people and answer questions like, what does my hashtag look like? What does your hashtag look like? How is your hashtag different from my hashtag? If I wanted to be like you, what would I do? And these maps, you know, if you were trying to open up a new Starbucks, you might look at maps and decide this is a good location and not that location. Similarly, you might want to figure out, how do I intervene in a network? And so those are the 6 types again. And it's worth noting that a lot of people give up after phase 1. They're delighted to have gotten an audience, but they don't realize that getting fragmentation means that people are starting to be aware of you without having to hear from you. And then there's phase 2B. That's where your audience is starting to get an audience. This is what it looks like to have a brand champion talking about your product. This is you talking about your product, but now somebody who heard you is talking about your product, and now other people are listening to them. But all of this pales in comparison to the ultimate goal. As a sociologist, I think we should all agree that the ultimate goal would actually be multimodal, multiplex, reciprocated relationships. And that would mean community. And so it's worth asking the question, just how social is social media? And the answer is not very. Just how much community was in online community? Answer, not much. And how do we know? Well, that's not social. Even this, that's not social. That's an audience. This is social. This is community. This is lots of people talking to lots of people. If you sit down at your family dinner table and only one person is allowed to speak, that's not a family. Well, maybe my family is sometimes like that. Maybe yours is. But okay, it shouldn't be like that. Everybody's supposed to be able to talk to everybody. And that's what this might look like. And so there are different shapes and structures in these spaces, and we want you to be aware of that and consider potentially navigating from one shape to another. Some shapes are better than others for certain purposes. Is there the one shape that's always better than all the others? No. But are certain shapes better for certain goals? Absolutely. If you're trying to be a celebrity and you got the brand pattern, that's not good. And so this is a little bit of a guide to where am I now and where do I want to be? And how do I get there? And so the goal in this image is to go down the rows until you see the pattern you are, and then to go across the columns until you see the pattern you want to become. And at the intersection, we're trying to convey the idea, is that going to be an easy transition? Because not all transitions are easy. Is that going to be a desirable transition? Not all transitions are desirable. And what would my KPI, my key performance indicator, what would my compass needle, my North Star be? How will I know if this is going in the right direction? I need a metric. And so I'm going to use a network metric to tell whether or not the ad budget, the new advocacy campaign, the new effort to reach out to influence, is it working? This is how you would measure that. So I have a short rant, which is about where we are concerning misinformation and disinformation. I would like to know if I could do that in about 3 minutes time and then turn over to the Q&A. Would that be acceptable?
Yeah, that sounds good.
Thank you very much. So I just want to put it this way. We are sort of in this moment of disinformation, misinformation, propaganda, fake news. And it's a confusing moment. It's a time where it's easy to get dizzy. And the problem, I think, is we are not yet aware or ready to implement the things that make information systems high quality information systems, which is to say information systems give transport to any bit pattern, whether or not it's true. And so we didn't build a truthful internet, we built an internet. But there's a problem with wanting to build a truthful internet, and that is this. Information quality is not the same as validity. How much time do people spend in fantasy? Well, if I open up Netflix, you got to dig deeply to find any documentaries. It's not easy to find. but there's lots of stories about space aliens and pirates and all sorts of stuff. And none of it's true. How many hours a day do people spend consuming information that is not valid, but has quality? And, you know, it's hard to imagine, but like the whole Star Wars universe, it's not true. No Darth Vader, no Death Star, no lightsabers, no Force, no X-Wings, no robots, none of it's real. Didn't happen. Not in this galaxy, not in another galaxy, not a long time ago. It didn't happen. And yet we spend a lot of time and money wallowing in information that is not valid, but has, for us, quality. And so we're now in a state where the stories become the dominant story because the story is good, not because it's true. Truth is boring, it's dull, and it disagrees with my political goals. And I think what has happened is many political organizations and commercial organizations have realized that truth is very much in the eye of the beholder. And what you see is what you expect to see. And so if we can teach people to think that this is what they're seeing, that's what they're going to see. And there is a line in sociology, I should add it to the slide. It's from the early days in the 1930s of American sociology, and it comes from W.I. Thomas in a book called The Polish Peasant. And it's all about the millions of people from Poland who moved to Chicago from 1880 to about 1910. We had about 3 million people move to Chicago. And the line goes like this: things are real in their consequences. If you think something's real and you act as if it's going to happen, then it might as well have been real. And so we are faced with a real challenge. There is a kind of weaponization of social media, propaganda, misinformation, disinformation, stop the steal, don't wear a mask, COVID is a hoax. Some of these ideas are quite dangerous. And so some people are getting good at manipulating this marketplace of ideas, of creating the stories that people want to hear rather than the stories that are actually reflections of reality. And part of the problem is that the platforms are designed only to amplify, never to diminish the distribution of information. That everything is about going viral, but having gone viral, there is no mechanism to hit the brakes. Only Mr. Zuckerberg himself, or maybe Mr. Twitter himself, can stop some kind of spread of information. The platforms themselves don't enable that. In other words, you have a retweet button, but there is no detweet button. And so the idea of the marketplace of ideas is that a rising tide lifts all boats. We all gain a certain amount of power from the new communication technologies, but the reality is that some boats rise better than others. And the boat at the crest of the wave there is the boat that does not care about the factual quality of its information. Doesn't care, doesn't need to. You know, Texas is having a big crisis right now. It's because of solar panels, they say. But it's not. But, you know, if you get out there with your story fast, you can win this race. And so we, the Social Media Research Foundation, are trying to imagine in what way could we change this circumstance without trying to come up with better quality human beings. Don't think that's going to happen. What we might need are better quality institutional frameworks and tools to get better quality behaviors by making them rewarded, and to diminish low quality behaviors by making them costly. And so we are arguing that there are 3 things that researchers and sociologists and technologists we're advocating, work on. And that is detection, deflection, and deterrence. And we're going to label deterrence with a question mark because maybe it's ethically dubious, but the first 2 are not. And that is, are you being attacked? That's detection. Do you have the tools to actually know? Then there's deflection, and that's, you are being attacked. What will you do about it? At the moment, the answer is, I have no idea. There is no button I press that says shields up. And then deterrence, I'm an American. So, you know, deterrence is when we say, don't do it, because I would come over there and do it to you. And I put a question mark there because frankly, that is ethically dubious. It's like nuclear weapons. But I'll just say a few words on behalf of nuclear weapons. It's about 80 years in and no nuclear war. So, you know, I don't know. It's a complicated issue. So there are people who have studied what it takes to create social spaces that are healthy social spaces. One of them is Jane Jacobs, a sociologist, an urban sociologist. And one of her arguments is it's going to take awareness of what's going on the street in order to assure that what happens there is acceptable. And she was arguing that, you know, having older people staying at home during the day back before COVID meant that somebody was actually looking out their window and could see that somebody has just broken into your house and was stealing your television set. So we are in a complicated moment in culture. And what we would like to do is avoid this. This is throwing the baby out with the bathwater. And what we don't want to do is give up rights of free expression. We don't want to create a license for speech, because the more we constrain speech, the more likely our speech will be constrained. At the same time, we do not want to do this, which is leaving the castle gates open so while the invader is on horseback coming towards us. And that means it isn't the case that we're not under attack. All liberal democracies are having their civic discourse invaded, manipulated. And so we need to be somewhat aware of the fact that a lot of people don't believe that corona is real, that they don't think that masks are real. They don't, you know, they've got some confused ideas that could be very harmful to the society as a whole. And so we're just going to make a few suggestions that the platforms could do things that would adjust the circumstance. You know, you could imagine very easily Twitter adding the editor button. And so now I not only follow you potentially, but I've got this editor button. I did that in MS Paint. And when I click the editor button, suddenly if you deleted a tweet, if you marked a tweet for not to be displayed, and I think you're my editor, I don't see the tweet either. Why would that be good? Well, you know, the Southern Poverty Law Center might want to clean my Twitter feed of all the Nazi racists before I get up for breakfast. And that way it kind of reduces the incentive for Nazi racists to produce Nazi racist content, because I'm not going to see it. And I'll note that when they got kicked off of Twitter and they went to Gab, and then they went to Parler, their activity dropped because they were talking to each other. It wasn't as much fun. And so little architectural tweaks could change how the platforms work. And one of the issues is that we think that they are data banks, but in practice, they may be data casinos, that they're not really the places where we should store our data in a place where we want to earn interest and be able to withdraw that interest. And so in a lot of ways, these things have created marketplaces of ideas. And in those marketplaces, let's see, there we go. Hello. Those marketplaces of ideas don't have accounting systems. And if you had a marketplace and it had no accounting system, you might expect rampant fraud. We have a social media environment, which is a kind of like marketplace of ideas, but it has no accounting software. And so we should not be that surprised when our marketplaces are overrun by fraud, because there are no accountants, there are no chartered accountants, there are no CPAs, there's no auditor, there's no audit, there are no books. And so I'll just wrap up by saying the goal of NodeXL is to be a kind of accounting package for hashtags. It's the beginning of social accounting. The accountants have this notion of GAAP, generally accepted accounting principles. We are exploring social GAAP, the generally accepted social accounting principles. I guess that's GASAP. So it's not gap. So the idea is, how do we measure a hashtag? And how do we know when a hashtag is acting abnormally? And how do we track the people who create high quality and low quality information, and in some ways increase the costs of generating low quality information? So with that, I hope that NodeXL has proven itself to be a useful tool for you. I think we'd like to do some Q&A. That was my rant. It took longer than 3 minutes. I'm sorry, Wasim. There you go.
Yep. So I recorded some questions that came in at the start, so I can fire them across to you. So there were a couple of questions on whether NodeXL could handle other platforms, things like TikTok, whether you had Instagram recipes, and there was a question about LinkedIn as well.
Yeah, so many of those platforms do not have an API that will enable network data. So LinkedIn does not. Instagram no longer does. It did, it does not anymore. Why would they do that? Because they don't like external scrutiny. I mean, if you were a big company and you could avoid regulatory requirements that involve disclosure of your financial activities, you would. And a lot of businesses that once were public companies become private companies because they don't like the disclosure. And Facebook is one of them. And so part of the answer is not all platforms want us to get to their data. And as a result, we have a harder time. Now, having said that, if you're willing to do what, let's say, Dr. Diane Klein has done and actually go through Instagram and notice that so-and-so has mentioned so-and-so, and you encode that in a spreadsheet, we are definitely there for you. And Harold may have a point about there are some tools for getting Instagram data, but it's just not really network data. So I hope that answers that question.
But I have to add that there are these commercial providers like Brandwatch or Crimson Hexagon, and for a fee of a couple of hundreds US dollars per 10,000 tweets, you get data that can be converted into network data sets. So there are ways, but that's expensive. And about LinkedIn, I think there was a ruling 2 or 3 years ago when somebody scraped data, and the ruling by a court was, so this is okay. So if I have not taken a closer look at how to get to LinkedIn data, but apparently there are ways, maybe not that obvious and easy, but there are some cases.
Can I take Rosie's question about what our next session will be like, the advanced or the intermediate class rather? Intermediate is going to add deeper exploration of things like YouTube and Wiki networks. And we will go into a more step-by-step review of automation. So you'll be expecting to get out of that session the ability absolutely to run your own automate and to manipulate and change, customize that automation.
And just to add also in the advanced session, there's also a little bit about how to export from NodeXL into a program known as Gephi as well, and how you can use NodeXL analytics in Gephi, which produces different visualizations, but still using NodeXL's analytics and analysis. So we had another question on whether there was misinformation-based data sets on the NodeXL graph gallery.
We find that customer satisfaction goes up when I show you my dog. Could you repeat the question?
So on the NodeXL graph gallery, are there collections of data sets around misinformation as well?
And I think I put a couple of the links in there, and if you look for the word misinformation and disinformation, you will find maps of those words themselves. But then you're also going to see hashtags that are themselves mis or disinformation without using that word. So for example, there is the hashtag stop the steal. One could argue that that is disinformation, and that the way that we can address the question of disinformation is by mapping topics like stop the steal, or there is another one, Fauci fraud. And Fauci is the head of infectious diseases in the United States. And some people want to argue that COVID doesn't exist for a variety of political goals, I assume. And so there were many days where the hashtag Fauci fraud was a trending hashtag, and we often would map it on those days. So there's both the word misinformation and disinformation, and then the objects of misinformation and disinformation, and both are being studied in the NodeXL graph gallery.
Great. And another query, if someone asks, is there any way to exceed the 18,000 tweets NodeXL provides? So for instance, if someone wanted 0.1 million tweets, how would they go about that?
With some diligence is the answer. There is a switch in the import menu in import options. So that's NodeXL data, import options. And it has a little checkbox, and it says, before I import data, do I scrub the workbook clean? And if that's checked, every time you import data, it's as if it was a fresh workbook. Uncheck it. And now every time you run new data, it will append it to the end of the workbook. So one way to get to 0.1 million is to do that 5 times, maybe 6. Now, is that going to work without possible error? No. If you do that every hour, there's a very real chance that you've collected the same tweet twice. We wouldn't like that. And so now you have to do a number of manual operations to ensure that you have not duplicated. So how could we do this better? Well, you could do it separately, like slices of sliced bread, and then try to glue the loaf back together. And there is a way to do that by simply taking all the tweet IDs out of multiple data sets and tossing that into our tweet ID importer. And you might have 100,000 tweet IDs. And then NodeXL knows that it'll never collect the same tweet ID twice. It'll never import, it always uniques it, and it cleans everything up nice and neat. So instead of trying to actually get the scissors and the paste out and glue the data sets together, we recommend just grab the tweet IDs from multiple data sets, slap them in, let NodeXL do it.
But I can add that if you're using the...
I think Harold has a follow-on. Go ahead.
If you're using the users network importer, then you don't have the 18K restriction. And so what I did once was download 1,000 tweets by each of the members of the German parliament. So, and then ended up with almost 500,000 tweets in the data set. Then that obviously has to be narrowed down to fit into the analysis, but it does work, you get that. But so in that case, it took like 10, 12 hours to get 500,000 tweets, but that's just only based on the user network importer.
Yeah, so the size of the data set is sometimes a fixation. I need 1 million tweets or something like that, but it may also be the case that a very nicely pruned data set is better. And so not just, let's say, Trump, but Trump and some particular topic is likely to get you a better result set than just Trump. Or, you know, we'll soon stop using those examples. It'll be great. And so volume is going to be an issue because it's a desktop. You only maybe have 8 gigabytes, maybe you only have 16 gigabytes. And so I will just say one way to trim a network is to delete people who only have 1 connection. And that might simplify the graph. There are a lot of ways of trimming it down. Let's say adding a number of keywords that say it's not just Tesla, but it's also Tesla and service. because we all think Teslas are great until you need to fix them, and then all of a sudden they're not so great, right?
Also,
and so,
all tweets that are self loops before the analysis, so they don't have any impact on the network itself, but on the content analysis, obviously. But well, sometimes they're really maybe half of the tweets are self loops, and they don't impact the network, and you could remove these also.
you might also do a long time period and discover that only 1 day or 1 hour of that time period is really the spike moment, the peak, and then narrow your focus to just that moment. And so it's not always the case that you can get your arms around huge amounts of data. This is still a program running on your laptop or on your desktop, but it also may be the case that you don't need to, because many topics of interest are much narrower. I'll give you an example. We've worked recently with a graduate student in Australia who wanted to study fad diets. And if you type into Graph Gallery the words keto or paleo or low carb, you will see this graduate student, her name is Melissa Eaton. She mapped those topics every week for 6 or 7 months and was able to say, and she was I think she's now a doctoral student in a nutrition program. So she studies nutrition. And one of the interesting findings was that when she looked at all these diet topics, she asked the question, how many of the people who are influencers have a degree in dietitian, have a dietitian degree or a nutrition background? None of them. None of them was the answer. And so one interesting takeaway was her journal article that's coming out of this work is making the proposal that the dietitians and the nutritionists have a professional responsibility to get themselves into Twitter and start smacking back these arguments that, hey, it's perfectly fine to just eat pineapple. It's good for you. Just do that. You'll lose weight. It might not be a good thing, but the dietitians and the nutritionists have essentially abandoned the battlefield. They're not there. And people who want to sell you protein shakes are there. And they really want to hold that territory because it's a profitable territory. And so it may mean that each of us here are part of one or more professional associations, academic disciplines. It may be that once we have a kind of social media radar or accounting software, that removes the last obstacle for our professional associations to have a responsibility to act as a kind of lifeguard or a knowledge police and say, stop saying that. That's not true. How do I know? I have a PhD in knowing that that's not true. That's how I know. So most of the time we're just giving up those battle spaces to the people who want to profit from this information. So did that address that question, Wasim?
Yeah, so that was a great answer. And I think most of the other questions that we got through, we were addressing them in the chat as well. So I don't think.
Should we let our participants ask any questions if they have any remaining questions? If anybody just wants to. Can I ask one? I have one request though. Could we all can we all turn on our cameras and we'll take a group photo? Would that be okay? I'll get my print screen button going. There you go. Oh, thank you all. Yeah, I get my hair. Okay, here we go. And we'll wait just another moment, and at the right time, we're going to ask you to say think link. Okay, here we go. Oh, thank you. And there we go. And I'm going to take one quick screenshot now. There we go. And one more. Awesome. Smiles, everyone. Move that off to the side. And then one more. Okay, here we go. Very nice. All right. I thank you so much for your participation. For those who are interested in a follow-up, you can email info@smrfoundation.org. And, you know, depending on your time zone, either myself or perhaps it'll be Harold or maybe Wasim, we'd happily set up a time to chat with you and hear more particularly about your research goal. And maybe we can get you over those first few stumbling blocks that get in the way. But often people start swimming after about 3 or 4 hours of playing with NodeXL, and they're off doing their thing. All right. Well, thank you so much for uncloaking. I appreciate it. Nice to see you all. Hope to see you at a future event or in a one-on-one discussion. And I very much would love to see a network map from you all up in the NodeXL Graph Gallery, and maybe even a publication showing up in scholar.google. So with that, I want to say thank you very much to Wasim for our organization today, and for Harold for his presentation as well. And thank each and every one of you. So that's, thank you. Okay, and that thanking all of you. Team NodeXL is here to help. We'd like you to get to success with your research endeavor with a network. Give us a call. We can help. All right.
Great. Thanks, everyone.
Bye-bye.
See you.
Bye-bye.